everybody and welcome back to React Native EU 5th edition. We are once again streaming remotely from Callstack office in Wrocław, Poland. And I will really welcome you all in a second day of our conference that is going to be equally exciting as the previous one, full of technical talks. Before we start, once again, let me remind you that there is a Discord channel where you can discuss all the crazy ideas, share your experience and knowledge, as well as ask questions about the talks that we will answer on our React Native Show podcast. You can also tweet with React Native EU hashtag. You can do it right now as we speak, so that your friends can know that you are joining our stream and they can join as well, and they will not miss what we are about to explore. I guess that's a good moment to start. So the first panel is all about developer experience and tooling. Yesterday we have talked about building apps smaller at a scale using several different libraries. So that's all been focusing on building applications in general. Today we're gonna talk about developer experience and tooling. In other words, how we can make sure that we can work with React Native in an easier, faster way, and how we can support and address some of a more advanced use cases. Our first talk from this panel is going to be done by two speakers from Microsoft, Tommy and Lorenzo, and they are going to tell us how they are handling Microsoft's codebase. Quoting their brief, Microsoft is big, like really big, and I guess they're right. Their repos are huge, and historically we've been all discussing how Facebook is working at a scale. I guess you have all heard that Facebook has a mirror of React Native, how they are syncing back changes to the upstream on GitHub, how the pull request process works, how Facebook GitHub bot is working. But we've been all discussing Facebook codebase. Today, it's great because we can compare that to Microsoft, how they are using React Native at a scale, how they are managing the complexity of their applications, and all the best practices that they are adopting. And I guess that will be different from Facebook because every business has their own challenges and solutions. So, Tommy and Lorenzo, we are really excited about your experience and handling large code bases such as the one you have. So show us what you have prepared for us today.
Hello everyone and welcome to our talk. I'm super happy to be here. It's actually my first time speaking for Microsoft. It's really exciting for me. So today I'm going to talk with you about improving all the repositories. And by that I mean improving the RNZMS-DX, which probably for most of you doesn't mean anything. And that's, it's on purpose. It's a joke because you see at Microsoft we like a lot to use acronyms. So in this case, what I'm talking about is actually the developer experience when it comes to React Native at Microsoft. You see, at Microsoft, many things are kind of complicated or like super big and super, weird sometimes to interact with. So we decided to come here and talk to you about some of the challenges that we're facing and also present to you some of the solutions that we come up with, because we think that some of them you can probably take with you, both metaphysically and maybe technically. Let's start with one major concept. So as I'm saying currently, Microsoft is really big, and as a corporation with many companies and many products, we have a ton of different code bases, and many of them are monorepositories. And a monorepository is basically a big repo in which each folder is its own package, its own library, and it's aware of the other folder next to it. So it doesn't need to install through npm package.json. You can refer directly between the different folders. And we have many of those things, and sometimes we need them to even communicate among each other. So in a way to describe this complexity, we decided to go for something really big and complicated like the galaxy. And as you can see in this picture, we have decided to show the different monorepos as solar systems, because again, it's not just a planet, it's literally like its own living system where things work, but also sometimes you have relationship between those. So this is kind of like our starting point. This is where we want to, set the stage. So to introduce you to our cosmos, I'm going to be one of your astronauts. I'm Lorenzo Sciandra. You may know me as Callstack. I'm a senior software engineer at Microsoft, and I'm also a React Native maintainer. And with me is
Hi, I'm Tom Nguyen. You may know me as Tito64 on GitHub. I'm a principal software engineer at Microsoft. Long-time open source contributor, but first-time speaker.
And we're really excited to be both here. As you can see, we come from two different solar systems, which is like one of the cool things about being in this kind of big company. And also, as is one of the reasons why we decided to work on these problems, because we're from different parts so that we can collaborate. But before we do that, Tommy, how about you tell us a bit about, how React Native came to be at Microsoft? Let's start from there.
Sure. So, as in most companies, whenever new tech comes out, like React Native, someone needs to go and do the exploration work. And that someone, at Microsoft was basically the Skype folks, what they did a few years back when they rewrote their mobile app as a greenfield React Native app. And thereby demonstrating that you can use JavaScript to create delightful experiences and still achieve native performance. And I think what naturally followed that was that other teams started looking into ways to leverage this new technology to bring existing features that were written for web at the time, and then bring them to our users on mobile devices, on their PCs, laptops, and so on. And that's essentially how the brownfield approach started at Microsoft. Today we have React Native experiences in many Office apps, including Outlook and Teams. But we started out with one team making a proof of concept that got copied by other teams, that again got copied by other teams, and so on. And that way, the approach organically grew within Microsoft. And that's also how this concept of experiences came to be. Previously, one would have to go directly into an app, like for instance Outlook, in order to write the feature that you would want inside of that app. But with the brownfield approach, you can now stay in your own repo, say repo A here, write your experience, and then when you're happy with it, you can integrate it into repository B here, and that will eventually be shipped into a product like Outlook or Teams or some other app. And that's basically how we kind of abstract away the complexities, of being writing one experience, but integrating it into many, many apps within Microsoft.
And that's pretty interesting, but also comes with a series of challenges, right? So let me kind of throw you some of the challenges that we're facing. As I was mentioning earlier, we have the system of monorepos, and sometimes we need to send code between them, as also Tommy was showing earlier. So, for example, one problem when we try to do this, and it comes to React Native experiences, is who keeps React Native up to date in each code base? Does it mean that every monorepo needs a team that knows how to do a React Native upgrade? Or even when you do the bump, if I'm on 61 and you're on 62, it doesn't mean that I need to rush to 62. Does it mean that we go together to 63? Or what if our configuration are even more different? What if I'm using Whole and you're using Metro, or I'm on 62, you're on 64, and we use different libraries? What if my code that I'm writing inside my code base needs to go on two different monorepos and they have different configurations? How can I make sure that it works for both of them? More in general, how do we handle open source libraries? What if I want to use React Native SVG? How do I make sure that everyone is using the same version so that the same code doesn't create problems? Some of these challenges are really, really complicated. And today, what we're going to try to do is dive on two of those. We have picked these two because they're kind of the ones where we know the answers and we think that the answers can be of use to you too. So let's start with the first one. How can we separate the developer experience from the complexity of the tooling? This is something that Tommy kind of briefly touched on, but I'll dive into it a bit more. And the second problem is how can we reduce the burden of alignment across different monorepos? This is what I was just mentioning. And by saying burden of alignment, what I mean is that we want something that is automated. We want something that doesn't need to rely on some human necessarily to do the entire alignment process every single time. But let's start with the problem number one, separating the developer from the toolchain. So bringing back up the graphic that Tommy was showing, what we can see here is that we have codebase A, we have the developer working on the experience, and then this goes into codebase B and then gets deployed into the host app, in this scenario, Outlook Mobile. How can we make sure that the developer is capable of creating the experience, test it, and then it will go through correctly? Some of you may think, well, you can just give the host app and the codebase B to the developer so that they can build the app and then they can see the feature working within that app. But when you're a company of size of Microsoft, this is not viable. There are many different reasons. There are security concerns, there are authorizations problem, and there's also like a more practical reason, which is if you were to keep two massive code bases on your machine, and every time you need to build the final host app, it takes 30 minutes, it would be a lot of time wasted and a lot of processing power that needs to go to, for maybe you're just developing a small sub-page with a button. You don't really need the entire app to work. So what we decided to go for, and what we want to achieve, is basically the idea of a sandbox, something that you have locally in your code base that replicates well enough the environment that you will have in the final host app so that you can develop in isolation. We call this sandbox the React Native Test App. And the way you can think about it is basically kind of like a React Native init app, with the difference that it's way less complicated because we squashed most of the complexity below the surface. And by doing so, it means that the developer only needs to have it set it up, and they can just put their JavaScript code in there. They don't need necessarily to worry about the native side, and they just can keep iterating on it. In that sense, it's kind of similar to the Expo client, where the developer only needs to worry about the JavaScript code and not necessarily about the native. But when it comes to it, and this is probably the difference with the Expo, is that our React Native Test App allows you to modify whenever, in whichever way you want, the native code. And also, thanks to hiding the complexity of the native side, we are also able to support many different versions of React Native all at once. And you will see soon what I mean by that. Because, it's fine and dandy to say that our solution is perfect and it's really, really good. But a completely different thing is to show it to you. So, Tommy, how about you do as Sun Tzu says here and show us how React Native Test App works?
Sure. Let's start with integrating React Native Test App into React Native Web View. So here you see that I have a clean checkout of React Native Web View. Just to show you, there's nothing I have done in here. So the first thing we'll do here is to move the existing example app out of the way. Right, and then we'll install React Native Test App, and then we will initialize a new test app. We will call it WebView Example for now. And then we'll select the platforms that we will support. I know that WebView supports both Mac OS and Windows, so I'm going to keep those. Now, let's have a look inside this newly generated app. You can see that it's very bare bones. There's a few configuration files. Inside of the iOS folder, there's only a pod file. The Xcode project will be generated much later. For now, let's copy over some of the code from the previous example app. And that's it. Now, before we build, let's take a look inside package.json. You can see here that when we generated the new app, React Native test app will try to match the React Native version that the library is using. I'm going to bump this to 62.3 because I'm using Xcode 12.5 and I want to avoid build issues. Next, I'm going to add React Native Web View. Right, and then we will run yarn and pod install as we normally would. And then we'll start the build. So in a moment, we should see the WebView test app launching. And just to show you that it works as normally, I'm going to click around this button here. And if we go back now, we see that we are running React Native 62.3. But setting up the new app, that's the easy part. Let's have a look at how you would bump React Native. If you've done this before, you know it's not a very easy process, especially if you're unfamiliar with Gradle, Xcode, or Visual Studio. So now we need to bump a few packages inside of package.json just to make sure that we don't hit any issues. We're going to bump these as well. All right, now we're going to run yarn and pod install just like before, but we need to remember to clear out the pods files just to make sure there are no old files lying around causing trouble. All right, now we can run pod install again. And we'll start the app just like before. And there we go. That's it. You can see it works just as normally. I can click on this thing here. And if we go back, it says that it's running 63.4. And that's how easy it is to bump React Native using React Native test app.
That's pretty dope.
So, as you see, previously when we had I briefly mentioned that we copied the patterns from other teams, and sometimes we would verbatim copy the test app code as well. And so many teams had their own test app, and so they had to maintain their own test apps. And whenever we did a bump to React Native, they would all have to go and upgrade their test apps as well. And so, it's time consuming for everyone, but with React Native test app, you have a single test app where we do the bump, and then the teams using it just need to do a bump inside of package.json, and then they don't have to worry about tweaking the project files in order to make it work, and other not all people have domain knowledge within Xcode or Visual Studio in order to do this. Now we basically hidden away all of the complexities inside the React Native test app, so you don't have to worry about it. And the nice part about it is that when there's a fix or a bug, you can apply them once inside a React Native test app, and then have them propagated across all of the teams, and they will all benefit from it. If you have a new feature implemented inside a React Native test app, everyone will benefit from it, not just your own team.
And also because it's it works on so many platforms, it means we can help a lot of people at the same time. So it's either iOS, Android, macOS, or Windows. It works with all of them. So that's pretty interesting too. But let's stop this hype train about React Native Desktop and let's go back to talking about problems. That's what I like to do, talk about problems and complain. So let's talk about aligning the monorepos, the second problem I was mentioning. So as I was saying earlier, it could be that you have your monorepo and you're using React Native version X, but maybe there's another one, and apparently, yeah, they're using React Native version X, but then you realize, oh, I'm using package B version 2, but they're using version 1, or what if they're using React Native version Z or React Native version Y, and what if they're using Hermes, but I'm not? Like, there's a lot of independency between these different monorepos, but this can lead to problems when it comes to sharing code. So basically what we need to ensure that these kind of problems don't arise is some sort of like antenna that propagates a signal to all these different configurations and kind of aligns them. We have decided to call this tool, this antenna, DebCheck. Basically, this tool understands the structure and the dependencies within a package.json and can modify it based on a series of curated profiles. What happens is that DebCheck can read through all the different dependencies, and let's say you told the tool, hey, I want this package to be ready for 64, then DebCheck has a profile that tells it, okay, if you're on 64, you need to be using React Native SVG this version. You need to be using React this version, and it will modify the package.json accordingly. And not only that, but it can even fix misconfigured package.json. Like if you're using a library, or like you're working on an experience which is a library that then you send to a different app, you need to configure, for example, the peer dependencies so that whenever another package consumes you, they know which version of things they need to use. So sometimes that can kind of fall off because it's not strictly mandatory. So this tool can also fix the misconfigurations, and you'll see that in a few minutes. Also, another really interesting part about DebCheck is that since it's a CLI, it can be mostly automated. But let's stop talking about it. Tommy, how about you tell us a bit more about DebCheck?
Sure. So in this monorepo, we have hundreds and hundreds of packages. Let's imagine that. So in this repo, there's a nice library that we'd like to consume. This library is already configured to use RNXKit. You see that it has support for 63 and 64. This is also reflected at the bottom in the configuration here. But it has a direct dependency on React 17, which is troublesome because React Native 63 will install React 16. And if you're consuming this package, you will get both 16 and 17 installed. And that will cause issues. Our next DebCheck will fix this. You can see here that it tells you to remove React from dependencies and move it down to dev dependencies. And then under peer dependencies, it tells you to add 16 and 17. And this is all according to the configuration that you put at the bottom here. Let's have a look at another library. So this one is actually perfectly fine. Everything is correctly configured, but I want to add WebView, but I don't know which package to use. So I'm going to open this up, and in the configuration section down below here, I'm going to say I need WebView capability as well. So one of the things that RNX DebCheck does is that it will suggest which package to use. And in this case, it will be React Native WebView at 11.4.2. That's pretty neat. Now, let's have a look at an app that consumes both of these libraries. So here's one app that consumes another library and nice library. It also has a slightly older version of React Native, but that's okay. We'll fix that in a bit. So we run rnext step check, and you'll see that it tells us to bump to 64.2. And also, by the way, it picked up that another library has a dependency on WebView and tells you to add it as well. But all of these so far depend on a configuration. What if you have a package that don't have a configuration? What do you do then? Well, rnext step check hopefully will be useful in that case as well. So here we have a test app that doesn't have a configuration. It also has the same problem as the previous app, that it's using a slightly older version of React Native. We're going to add a flag here called vigilant and tell it to use the 0.64 profile. Basically, that will tell us that we want to use React Native 64, and it will tell us that we should probably bump it to 64.2. You can also use this tool at the top level of your repository, so you can get an overview of all of the problems that we've seen so far. You can see here it just dumps all the problems that we saw earlier. And then to fix this, just add --write. And it should fix it up. We'll see that in the git diff here. All of the changes that it suggested earlier has now been applied, and you need only commit this and you're done. So this is how we use this internally, is that we integrate it directly into our CI. We run it every time a PR is submitted, a build is started, and so on. The rnext step check runs, and then it will tell the user if they need to make any changes to their package JSONs. And the way we have also integrated it so that it will actually post a comment on the PR with suggestions, so that you just click a button and the suggestion gets applied directly onto your branch. So this ensures that everyone inside of your monorepo are using the exact same version of React Native WebView, and what have you. But also, since many monorepos are using the same tool, we ensure that they are all aligned. Additionally, if your monorepo publishes a lot of packages, what you can do is to export a custom profile and say that, for React Native 64, you should be using these versions of my packages. And then you export that profile to other monorepos. They can apply that to rnext step check, and thereby making sure that they also stay aligned on the correct versions of the packages for the respective React Native version.
And that's super powerful, in particular for what we were saying earlier about removing the burden. It's awesome. So now, trying to recap a bit, so React Native Test App, we introduced that to separate the developer experience from the complexity of the tooling, and Dap Check, as we were just saying, to reduce the burden of alignment across different monorepos by relying on the automation. Now, so we are kind of like concluding here. So as we were mentioning at the start, I wanted to go back to the fact that these are basically byproducts of the lessons we learned the hard way, the challenges that we were facing. And while we realize that Microsoft is a really big company and not many of you may have the precise experience that we were having, you may still find some challenges that are kind of similar. Like, what if you have a React Native library and you want to make sure that it's configured correctly? What if your library doesn't have a test app, or like you added it, but it's always out of date because you don't have time to upgrade it? These tools could be useful for you too. So how about we make this tool open source so that you can use them? I mean, this is the oldest trick in the book, but hey, we're introducing you all the different tools that we were just discussing. So React Native Test App and DebCheck are both available through the repos you're seeing right now on screen. React Native Test App is in its own repo, and then DebCheck is in the RNX Kit repo. It's one of the packages in that monorepo. Also, you can find in RNX Kit quite a few interesting small little tools that may be interesting. So check out the repo and look at the other elements that you may find there. Anyway, thank you for listening. We hope that you will, find a little bit of happiness in using these tools for yourselves. And we hope you're enjoying our conversation. I was Lorenzo, with me was Tommy. We're really, really happy to be here. And feel free to shoot messages our way and ask us questions. All right, goodbye.
Goodbye, and thank you again.
Thank you.
Thank you, Tommy and Lorenzo, for this talk, and I guess I wish all of you that our code base has reached that size so that it's going to be a measure of the scale that we have reached, and I guess some sort of a success for our products. Now, moving to our next speaker, we have our very own Paweł from Callstack, and he's going to talk about code splitting with React Native. Now, code splitting is a concept that is probably more popular within web development, where you can actually split your JavaScript bundle into smaller chunks so that if you have a large code base, you don't have to load everything at the same time, but you can actually load chunks so that your users get your code faster, the critical business logic is loaded faster, and it's just that if your application is large, you can optimize some of the issues that arise as a result of the large size of the application. Now, with React Native, this sounds rather crazy because most of the time there is only a single JavaScript bundle. We load everything from the disk, so why we should even code split our JavaScript bundles with React Native? I guess Paweł has prepared some of the most unique and crazy use cases for us today as an example that Repack, the library that he has created, is just something that you should be using as of today. So Paweł, the stage is yours, and show us what you have created with Repack and why we should all be using it when our applications grow.
Hello everyone, I'm Paweł Trysła, also known as Zamotan on the internet, and I'm a software developer at Callstack. Today, I'm going to talk about code splitting in React Native. So, let's start by answering the question, what code splitting actually is. Code splitting is a technique to split the code of your product into multiple bundles. Those bundles can be loaded on demand or in parallel. Instead of shipping the whole application's code to the user, you only deliver the bare minimum of the code and load the rest later once needed. Now, before we move forward, let's establish what a bundle is. In a nutshell, a bundle is a single file container for your code. It includes compiled source code, all necessary dependencies, and in some cases static files. You might be wondering why we need a bundle for React Native applications. Well, your project, in order to be executable by React Native, needs to be processed and converted to a format which JavaScript virtual machine inside React Native understands. We call this format a bundle, and usually in React Native applications, your project is contained inside a single bundle. But doesn't have to be that way. Let's talk about code splitting. With code splitting, the project's compiled source code, dependencies, and static assets are part of multiple files instead of a single one. The entry point to the application is included in the main bundle, sometimes referred to as an entry chunk, and it includes all necessary code for the application to work and minimal code to present something to the user. All additional features and logic are contained in the additional files called chunks. Those chunks can contain features needed later in specific situations or for specific group of users. There are two main usages of code splitting in context of React Native: dynamic content and feature delivery, which allows to provide certain features on demand or for a specific user or group of users. Secondly, there's an optimization use case. Because code splitting allows to load the code later on demand, it can be used to defer code loading until it's needed. This can improve time to render and time to interactive, since React Native has to load and execute less code initially at the startup. Let's look at some of the examples of code splitting in mobile applications. First example are so-called super apps or mini app stores. Those applications consist of multiple small, dedicated services, sometimes referred to as a mini apps. It's a closed ecosystem where service or a mini app is tightly integrated to provide a great and efficient experience for the user. Because a super app or a mini app store can contain tens of hundreds of mini apps, not every user will use all of them. Based on that, it would make sense to download and execute the code only for the ones that the user intends to actually use. And then the host application would initially only ship the core APIs and functionalities to the user. As for the example of super apps that exist on the market today, we have a couple of them, but the ones worth mentioning are Alipay and WeChat. WeChat for its sheer size of 1 million mini apps, and Alipay for a tightly integrated ecosystem of services that work together to provide great experience for the customer. So on one hand, we have super apps and mini app stores, but code splitting has use cases in other group of applications as well. I call them modular applications. It's an umbrella term of applications that could extract part of the functionality into modules loaded on demand or based on runtime factors like user role or group role, subscription plan, or preferences. Modular application description is especially fitting for applications heavily based on user roles. For example, e-learning applications or school-related applications, where we have vastly different functionalities for student and for teacher. So, based on the user role, the application could only load student functionalities or teacher functionalities. This would improve initial download size and startup performance. Another example would be companion applications for hardware and physical devices. We could put here most of the automotive applications where functionalities could be splitted into on-demand loaded chunks based on the vehicle parameters. Now that we know what types of applications can benefit from code splitting, let's see how code splitting can be implemented inside mobile applications. Let's start with Android. Natively on Android, we can use a feature called Play Feature Delivery. It allows to split native code into multiple bundles. It is even possible to embed React Native inside such bundle. In context of React Native, Play Feature Delivery can be an option for brownfield applications. But Play Feature Delivery has some drawbacks. The biggest one is that Play Feature Delivery is a native functionality, so it will be difficult to create architecture where JavaScript code uses the same JavaScript virtual machine. It would be much easier to create application with multiple React Native instances, each one in its own Play Feature Delivery bundle. This means that native coding skills and knowledge is required to pull off such architecture, and it will be mainly used for brownfield applications. For greenfield applications, though, the challenge to share a single JavaScript virtual machine will be a major blocker. On iOS, there is on-demand resources functionality that could be used to split some of the content like data, images, shaders, particles, and similar. However, native code cannot be an on-demand resource, which is a real blocker since we are looking for splitting logic by splitting the code. Even if we still want to split the native code without using on-demand resources, it would be extremely challenging due to the static nature of binary code, and more importantly, there is a high chance that it would be rejected by App Store review process, as it would violate the App Store guidelines. Okay, so it will be problematic to achieve code and content splitting natively on both platforms. Are there other options? Yes, they are, and web views are one of them. They are extremely easy to work with, and introducing them wouldn't be a difficult task. They can be used both in native applications and in React Native. However, they provide suboptimal experience for the user. Web views are likely to have performance issues, and they don't provide the native look and feel that you strive for. Luckily, there's React Native. With React Native using default JavaScript bundler called Metro, it is possible to create a cross-platform solution for splitting the code without sacrificing user experience, and the APIs to make it happen are already part of the React Native. You could use execute application script method on iOS and load script from file or load script from assets or Android, but you will likely run into troubles with dependencies deduplication and in general code sharing between chunks. The Metro bundler is not well suited for this, or at least it's not well documented. Splitting the code using Metro would also mean that for each additional chunk, you would need to spawn a new development server, and fast refresh would only work for the main bundle out of the box. It might be possible to overcome all of these problems, but it would require a lot of effort, knowledge, and skill. So what else can we use then? If you're coming from web or have background from web development, you might be wondering, why couldn't we use the same solution for code splitting in mobile applications as on the web? That's the same question I've been asking myself, and for React Native, I think we could. By using Webpack. It's a commonly used bundler on the web. It has huge ecosystem, lots of configurations options, and most importantly for us, well-established code splitting functionalities. However, if you tried using Webpack to bundle your React Native application, you would ultimately hit a major blocker. Webpack is not compatible with React Native, at least not by default. In fact, the plugin ecosystem in Webpack is so flexible that we could bridge this gap and make Webpack compatible with React Native, and that's exactly what we did. We named this project Repack. Repack is a toolkit that makes Webpack compatible with React Native. It enhances and changes the bundle that Webpack produces so it can be executed by the JavaScript virtual machine inside React Native. It takes into the account that the code in React Native runs in different environment with different APIs, needs different setup code, and so on. Repack itself was created as a successor to another open source project called Whole, but compared to Whole, it takes a different approach. With Repack, you still have access to Webpack configuration, and Repack gives you only the plugins and helpers to allow you to use Webpack in React Native applications. It doesn't hide anything from you. It gives you a fully featured development server, support for React Refresh, and compatibility with Flipper. Except for RAM bundles, Repack has a feature parity with Metro as of today. So if you want to use Webpack with React Native, the easiest way to do so is with Repack. Now, let's evaluate React Native with Repack and Webpack as a code splitting option. The first advantage is that the solution is based on Webpack itself, which has wide variety of configurations options, and we can adjust it well to our needs. Additionally, it has huge ecosystem community and it's widely used, meaning it's stable and an established software. Together with Repack, it's a cross-platform solution focused on code splitting, but everything has its drawbacks. Because it's Webpack, it has a high entry barrier, especially for less experienced developer. It will be challenging to configure Webpack if you don't have previous experience with it, so it can take up some time to get familiar with. The biggest point of Webpack, which is its configurations options, is a double-edged sword. It's powerful, but it can be overwhelming. Nevertheless, based on other options, it seems to be the best one, at least for the time being. Competition and alternatives are always a good thing. So, let's explore code splitting with Webpack and Repack. Essentially, there are three approaches to code splitting with Webpack and Repack for React Native: async chunks, dynamic scripts, and module federation. Let's start with async chunks, the easiest approach. The additional chunks are created from a single codebase as part of a single compilation, also known as bundling process. New chunks can be created by using dynamic import function, and the first argument for this import function is a path to a module which will become an entry point to a new chunk. Chunks created by this approach are easy to work with, since this approach only requires you to configure Chunk Manager to resolve URLs to remote chunks, and the import function returns a simple promise with chunks exported values. You can specify whether the chunks created by this approach should be a remote ones, hosted on the server on the internet, or remote ones, shipped together with main bundle inside the application. All of that makes async chunks an ideal approach for modular applications where the project consists of a single codebase. This code snippet is a simplified version of an e-learning application, a module application. We use dynamic import function together with React Lazy to create additional chunks and only load either of them based on the user role. The only thing necessary to use this approach is to configure Chunk Manager so that it knows where the chunks for the student and teacher will be later in production. Now, with dynamic scripts, the second approach, we are going onto a deeper water. Dynamic scripts are chunks with arbitrary code. The code that was created by the same or different bundler, by the same or different team, in-house or externally, with dependencies and code sharing or without any sharing at all. It's a powerful option, but with great power comes great responsibility, and you are responsible for putting it all together so that it works. If you want to share dependencies, you have to figure out exactly how you want to do it based on your project's needs and requirements. In this scenario, Repack gives you only low-level APIs to implement user-facing facade on top. This makes dynamic scripts approach more challenging, and it's recommended for more advanced users who already have experience with Webpack. This is the minimal example of how you could use dynamic scripts. It's a powerful tool since you can load arbitrary code. Similarly to async chunks, you need to configure Chunk Manager to specify where chunks are hosted, but you also need to manually trigger loading of the chunks using load chunk method. Compared to async chunks, the load chunk method is called manually here, but with async chunks, it's being called under the hood automatically for you. And finally, we have module federation. the cherry on top and Webpack's 5 new feature. What makes the Module Federation unique and exciting is the fact that it allows to create micro frontends, which can be developed in isolation by separate teams, but ultimately create one big application. Module Federation, similarly to dynamic scripts, allow you to create chunks, also referred to as containers, in separate dedicated compilations. This makes it great at scaling and give each team's ability to configure Webpack the way their chunk or container needs. However, they are the hardest to use and manage. Moreover, they require more elaborate quality assurance process to make sure that everything together works as expected. Module Federation is a great fit for super apps and mini app stores due to the isolation and scalability. Each mini app can live in a dedicated codebase and can have dedicated Webpack configuration. But when putting everything together, the main bundle in the host application can share and reuse dependencies with each mini app. This means that as long as the dependencies in host application and all of the mini apps are compatible based on somewhere, each dependency will be shared and no dependency will be duplicated. So Module Federation is rather new concept, and so the question arises. Is Module Federation available in Repack today? And the answer is not yet, but it will. From the moment Repack was created, we had Module Federation support in mind, and since Module Federation and both async chunks and dynamic scripts share internal logic, we are first focusing on delivering outstanding support for async chunks and dynamic scripts, and then tackling the big fish, Module Federation. So let's summarize the state of code splitting in Repack. The base implementation with basic feature is already implemented. You can download and execute remote and local chunks. You can leverage basic caching and invalidation mechanism. You can provide custom URLs resolution logic for each remote chunk. And you can do all of that today, and there are more things to come. From the upcoming bits, there are chunk signing and verification to tighten up the security even better and ensure the chunks the application is going to execute, it's what it's supposed to be. Additionally, we have advanced caching and advanced fetching options to support more variety of scenarios and infrastructures. Local assets support to allow to use static assets like images inside a remote chunk using a relative path, and of course more documentation and examples. This brings us to a conclusion. You can start investigating and playing around with code splitting in Webpack and Repack. You can use Repack APIs to build great experiences on top of. You can start migrating your project and investing into code splitting to later migrate to Module Federation when it's available. However, keep in mind that code splitting support in Repack is actively being worked on, so the final shape and API might change, and there are more features to come. So, thank you for your time. I hope you enjoyed this introduction, and I hope I was able to shed some light on code splitting landscape in React Native ecosystem. And lastly, spark a light of curiosity. So stay tuned, there are more exciting things to come, and thank you again.
Thank you, Paweł, for this talk. And from myself, all I can say is, congratulations on making this library happen. I know that Webpack and its ecosystem can be quite hard to dive deep at first, and I guess what you have created and presented to us so far is just a great example of what you can do once you dive deep enough. And I'm really excited to see what are we gonna all build with Repack in the future. Now, moving on to our next speaker from this series of talks, we have Monika from Equinox Media, and she's going to tell us about debugging React Native applications, so trying to answer the question, what went wrong? Now, I guess this is a very important talk because every once in a while at Callstack, we are doing performance optimizations for our clients, and usually the question that we are trying to answer at the first call of our clients is, how do we actually debug what went wrong? Now, React Native can be quite complex because you not only have JavaScript layer to handle, but also native layers, so there is quite a few different entry points that you need to check and quite a few different tools that you need to take into consideration while debugging the performance or any other issues that you have with your application. So Monika today is going to tell us how to actually do it, what are different tools, how you can utilize them, and essentially, I guess after this talk, we are all going to be performance optimization experts. So Monika, show us how to actually debug our React Native applications in a proper way.
Hi everyone. I am glad to have the opportunity to be participating again in React Native EU, especially in this virtual edition where more of us can get a pretty good idea of what has been happening in the React Native community for the past year, as well as with the library itself from wherever in the world we are located. I am Restrepo, a software engineer currently helping build one of the most innovative mobile applications dedicated to fitness and the well-being of our users at Equinox Media. Today, I would like to share with you some general findings about the most popular debugging tools for React Native applications. A topic that caught my attention recently while we were having a debate whether to switch fully to use Flipper or continuing using React Native Debugger for our debugging purposes. To be honest, the majority of my time working with React Native applications, I have been using the React Native Debugger as my main debugging tool. But seeing some of the positive arguments in Prof using Flipper and even Reactotron left me with the curiosity of exploring these other tools I knew very little about to see what were the pros and cons of each, so I could take informed decisions when it comes to picking my main debugging tool. Spoiler alert, Flipper and React Native Debugger ended up being similar in what they can accomplish. Reactotron ended up being a little bit of an outcast in this comparison, yet still offer some great functionality. But before we jump into talking about these debugging frameworks, I think it is very important for us, or at least it was very important for me, to talk about bugs. What are the most common bugs we often found within our applications? Multiple resources online point to many types of bugs that can really appear when developing mobile applications. Majority of these bugs are concentrated in these three different areas. We have app-specific bugs, platform-specific bugs, and those related to your app's architecture. App-specific bugs are the type of bugs we found more often within our apps. They are mostly usability and UI bugs. Network request issues are part of them, CSS issues, and broken buttons, for instance. Then we have the platform-specific bugs. When you have made your way into mobile development, mostly through React Native and the front-end side of things, like I did, you love this type of bugs. These are the type of bugs related exclusively to the platform the app is being run from, Android and iOS, for instance. Most of the time, these bugs are related to the way both operating systems work within the device and their native capabilities. It is very common for them to imply patchy solutions on the engineering side because both platforms could react differently to changes. Some of the most common things to cause us problems in our React Native applications related to platforms are scroll views overlays, view animations, transitions, and interpolations, deep linking, display properties, keyboard offset, and so on. And finally, we have bugs related to the elements of the app architecture. These bugs are related also to the business logic of the app. They are usually hard to detect by the programming eyes because they imply you have a very deep understanding of the business model and the app as a whole. Bugs in this area include things related to incorrect data flow or bubbling side effects for features. So for instance, a user that wants to join a specific group within the app and then changes to this user happen in other unrelated section of it. So what option does React Native offer for debugging besides our beloved and often a very useful console log. Let's start with Flipper. Flipper is a platform for debugging iOS, Android, and React Native apps, as I had mentioned before. Support for it was added to React Native since the version 0.62. This is the interface for Flipper. It obviously doesn't include the slides decor in the background, by the way. I personally find it to be really, really clean and easy to navigate. This is very important because debugging itself can be really overwhelming sometimes, let alone if you have to also untangle a complex UI. Flipper runs detached from the React Native debugger. It is a totally independent desktop application to which you can connect your mobile app given the right setup. This can be considered a pro for some of us, since we can kill some of the overload that the native debugger brings when running on some of our application threads. Some others might consider this a negative point, so it really is up to your workflow to determine that. Flipper main functionality lives in the App Inspect section. From here, we don't only get to access our app, but we can also connect to more than one application. The section below, where you see those 4 icons, allows us to bring the debugging menu out and even record and take screenshots of what is happening with the app at a specific time. Then we have the device section from which we can access the crash reporter and device logs. We have the React Native section as well, with access to React Native specific logs and access to Hermes when we are using either Android Studio or an Android device. Lastly, we have what I think is one of the most, sorry, I was a little off with that. Lastly, we have what I think is one of the most important parts of this debugger. This enable section here displays the plugins we have enabled for using during a session. Majority of our UI bugs can be found hidden behind failing props, failing CSS rules, and platform-specific things. This is where this section becomes really valuable. The layout plugin allows us to inspect the layout of our application. We can see here our views listed in their nested order, and then also a layout of the CSS styling those views every property of them. We can also see the accessibility properties available to each component, which is also very useful. Then we also have the shared preferences, which allows us to easily inspect and modify the data contained within your app's shared preferences. Things like the available keywords on either the emulators or the connected device, emoji configuration, privacy settings, and such are included in this section. When it comes to usability bugs, the ones that affect how your app works rather than how it looks, investigating network requests is perhaps the main step towards understanding what is going on when something is broken or not functioning as planned. Flipper's network plugin is very useful and complete to my point of view because it allows us to check requests and request bodies, headers and responses, and it allows you to also change the formatting of the responses, which I find really useful as well when you want to see everything in a more clear way, like in a JSON sort of way. If you work with Apollo, there is a Flipper plugin available that is fairly easy to install and use, except investigating caching issues might still be an issue. So this is where you get the plugins. If you use libraries like React Native Reanimated for your animations, remote debugging is not possible since the library uses GSI for synchronous native methods access. So this is a negative point for Flipper in this case. But Flipper becomes your best option so far for debugging code that uses React Reanimated, with the only caveat of Flipper not yet being able to connect the debugger to the JavaScript context. To finish with Flipper, I think it is worth mentioning that one of the things that I found Flipper is lacking right now is the fact that it doesn't allow you to set breakpoints, which to me, it is an important step on debugging data flows within an app. Other than that, Flipper is definitely a solid alternative to debugging your React Native applications. Let's move on into React Native Debugger. React Native Debugger helps you debug in pretty much everything Flipper does: layout props, metro logs, network requests, and so on, with the difference of allowing to use breakpoints. Among some of the good things of the debugger is clearly the fact that it is a functionality that is out of the box. You don't need to install a desktop application like in Flipper, if that is something that concerns you. I also found to be easy to debug Apollo and GraphQL issues, especially when it comes to caching exploration. But that is just a preference. Flipper also allows you to do this. Logs are displayed in a similar ways as it is in Flipper, as you can see here. So there isn't much to elaborate here. The source tab is perhaps one of the most useful ones. And knowing how to work with breakpoints in this one is definitely a booster when it comes to debugging data and components properties flows. From the source tab, we can see our file structure, set up breakpoints at pretty much any place within your file. Check for the scope of our code in which our code is being run within, and the Callstack for function calls. It offers also the option to check for your event listeners and such. When it comes to debugging network requests, I definitely found Flipper's interface to be a little bit more intuitive and easy to use. I don't consider this to be the strongest feature of the native debugger, yet you still can get a lot done with it. In the network tab, you will be able to check for the type of network request being performed and response times. If your application uses GraphQL, you can mix and match with the Apollo client extension for Chrome and get a pretty good understanding of your data flows and the cache, as I was mentioning before. The native debugger also gives you the opportunity to do some memory profiling and analyze performance issues. Features really valuable when it comes to upgrade your app's performance and identify what resources are consuming the most memory and taking the majority of a device CPU. In terms of some of the cons of I have found with the React Native debugger in comparison with Flipper, I would say that one of them is the not being able to install different plugins. Though so far I haven't found anything that I'm actually missing, but that point definitely goes to Flipper. The fact that the debugger runs with the debug mode turned on can also make your application a bit slower. It also depends on your machine, but it's also something you have to take into consideration. And as I had previously mentioned, inspecting network requests isn't the React Native debugger's best feature either. It has some known limitation, but you can always enhance your debugger for this particular task by categorizing some of your app's events by network event with some specific params according to what you consider is worth logging about. Luckily for us, if using React Native debugger for deep network analysis isn't enough, there is always Charles. All right. I think it is time for us to move into Reactotron. Let's take a look to what it can offer in terms of debugging our apps. Reactotron is sort of an old school debugger, similar to the two previous ones, actually. It is also a debugger, but besides aiming to debug only React Native applications, it is also useful for debugging Mac OS applications, Windows, and Linux applications. To get Reactotron up and running with your application, you need to also download the desktop app and make sure you configure it within your app. It is very similar to Flipper in this sense. With Reactotron, you can do pretty much the same things you do with the other two debuggers. Inspect network requests, dispatch actions using the GUI to see how the app responds to it. I think this is exclusively to Reactotron, actually. And I really consider it a valuable feature when it comes to aiming to understand the reasons for some usability bugs. You can also run quick performance benchmarks and subscribe to parts of your application state. Use logs, track global errors, and track your sagas for those of you using Redux. And show image overlay in React Native, track your asynchronous storage in React Native as well. Reactotron's UI is more or less similar to Flipper's with a few less features, such as installing plugins, and as well as Flipper, it doesn't allow you to use breakpoints. We can see here how we can also debug network calls, And this is the dispatch action, where you can modify what you dispatch into the actions to also see how your app will react to it. My conclusion after using these 3 debugging tools is that at their current state, you can really accomplish pretty much everything and the same things using any of them. As a matter of fact, I think I will personally keep at least 2 of them available for me when one or the other is either causing a lot of overhead in my app, like if I'm using the React Native debugger and things are really, really getting slow, or if I just want a more familiar user interface, then I'll go to Flipper, in my case in particular. Obviously, using React to Trump versus Flipper becomes kind of a business decision, since there is some setup that you have to do for them within the app. But once that is not an issue anymore, they both offer similar things to facilitate our debugging. I am going to leave it here with the hopes that you at least got more exposure to using other alternatives when it comes to debugging your React Native applications. Thank you so much.
Thank you, Monica, very much for this talk. I'm happy that we now all have better understanding of the different tools that we have. As you can see, this area is something that is developing quite rapidly. Some of the tools that we have just seen are something that was created quite recently. So it's good to see that we are investing our time and resources into making our developer experience better. Now, I guess after these 3 really exciting talks, it's the right time to make a short break for coffee and also for you to maybe ask some questions about the talks that we just had on our Discord channel. So make sure to do it while we enjoy our 15 minutes break, and see you, like I said, in 15 minutes. This conference is brought to you by Callstack, React and React Native development experts. Hello, I'm Mike, CTO and co-founder at Callstack, and today I'm looking for the best React Native developers to join my team. Besides working on high-end software used by millions, we also contribute to many open source projects such as React Native Paper, React Native Testing Library, or Repack. And so you will have an opportunity to develop your skills and knowledge within these projects, as well as move your own ideas into life by taking part in our R&D program. We are a great team full of people crazy about React Native technology, and we can't wait to share our knowledge and description with you. Trust me, it's great to be part of such a team. So don't wait anymore, join us, check out the job description in the link below and apply, and I'm hoping to see you soon in our Callstack office or maybe remotely depending on your location. Bye bye.
Wake up in Wrocław, get up and get at 'em. React Native EU is on and it's happening. Check in to check up on all of the latest news and strategy. Man, it's kind of the greatest.
Welcome to React Native EU 2019.
Keynotes that unlock a new world of insight. Lightning talks this cutting edge? It really seems so right. Networking with everyone in the React Native community, from the thinkers to the linkers, we're all here in unity. Q&As that dive deep into code DNA, and it's all covered here in only 2 days?
Especially when it comes to trouble.
After the last session, we're gonna party, okay? Food, drinks with good vibes and dope karaoke. High fives all around, it was good to be here. Can't wait till the next one. we'll see you next year.
This conference is brought to you by Callstack, React and React Native development experts. Welcome back after break. I hope that you enjoyed it. Now it's time for a series of two talks, two about animations and another two about security. So sounds like something that everybody should enjoy. If you're into animations or security, this is the right time to listen to our React Native conference. So the first talk is going to be about Grant from Formidable, and it's going to be about modern animations with React Native and an example of Reanimated version 2. Now, if you've been into React Native community for a while, you remember all the different libraries that we had for animations, starting with Interactions Manager, through the first iteration of Reanimated, up until to the second iteration of Reanimated, which has a totally different API and approach that is much faster, better, and just easier to do. So today, Grant from Formidable will show us how you can benefit from Reanimated 2, what are the animations that you can create, some of them on a more advanced side. So I guess it's a great moment to see how React Native apps can be fluid, fresh, and just smooth, which is something that we are all, as end users, are expecting from the applications. So Grant, the stage is yours, and show us what you have prepared as far as the animations side.
Hi there, thank you for joining me. Today we're going to talk about modern animating in React Native. This is going to be an introduction to React Native Reanimated version 2. So my name is Grant Sander. I'm a software engineer at Formidable. Formidable is a JavaScript consultancy. We use JavaScript tools to solve business problems for our clients. And so, as you can imagine, we're pretty big fans of React Native. It's great for building cross-platform mobile apps. So I want to start this talk with two pretty general and somewhat obvious claims. First of all, performance is important. So I'm not going to say much more about that. And also animation is important. I'm not talking like super flashy, crazy animations. I'm talking about like enough motion to show users when maybe app state has changed, or that like our app is responding to their gestures in a way that they would expect. So when it comes to mobile apps, performance being important is especially true for lower end devices. We often need to support Android devices, and usually like budget-friendly Android devices, which don't always have the strongest processors on board. Also, animation is very important for mobile apps, given that they're very gesture-driven. Users, interact with their apps, their mobile apps, with their fingers. They're doing finger gestures, and so it's important for us to give enough animation to give them feedback that we're responding to their gestures in a way that they would expect. So let's get a little more specific. Let's talk React Native. So first of all, React Native is a great abstraction. I'm a pretty big fan. I'm guessing most of you are as well. One of the things that makes React Native so great is this magical bridge, which allows us to basically write JavaScript code. It gets executed on a JavaScript thread, and then it crosses over this magical bridge and gets executed on the native UI thread. So the fact that this code is being executed natively makes it fast and performant, makes it feel like a native app. But we get to use our favorite JS tooling like React. So that's pretty great. But one thing to point out is these bridge thing, it's very magical and it's very useful. But trips over this bridge are not free. So we have to be somewhat mindful of how many times we cross over this bridge. If you're trying to do this every 2 milliseconds, you might notice some UI lag. So let's get even more specific. Let's talk animation in React Native, since this is what this talk is basically all about. So first of all, animation is important. We already kind of decided that. It's true in React Native as well. And when we're building animations in React Native, we want to declare them in JavaScript with nice APIs. We don't want to be like writing native code to create animations. One of the beauties of using React Native is most of our app logic lives in JavaScript, and we use React's APIs and the broad JavaScript ecosystem. And we also want our animations to execute natively with minimal bridge strips. We want our animations to be buttery smooth, as I like to call it, but they need to be performant. We want our animations to be at least 60 frames per second. We don't want a bunch of UI lag with our animations. So this means we want these things to execute natively, and we don't want to make too many bridge trips because that, might slow our animations down. So React Native actually provides an animated API for this. So this is sort of like the maybe standard way to create animations in React Native. But React Native's animated API actually leaves a little bit to be desired. It could be more performant. It could be more friendly to use. It could be easier to integrate with, gesture handlers. And so, you might be thinking, well, maybe there's a better way. So this kind of leads us into talking about React Native Reanimated. I'm just going to call this Reanimated as an abbreviated version. And Reanimated's been around for a while. It's on version 2 right now. They released version 2 just a few months ago. But version 2 is a huge, huge change from version 1. And it's very powerful. It's very friendly to use. And that's going to be pretty much the center of this talk. So first of all, why are we talking about a Reanimated? Why aren't we just using React Native's animated API? Well, basically because it can offer better performance and easier to harness. So that's great for power users and for people who are maybe not power users when it comes to animation. So it offers a simplified JavaScript API and mental model for performant native animations. So it's similar to React Native's animated API in the sense that you're writing JavaScript code that gets executed natively, but it's got a different API and a slightly different mental model for these APIs. And it also offers additional control over animations via these things called worklets, which we're going to talk about, but this allows us to have even more control over our native animations. And it also offers powerful integration with gesture handlers. And this is also very important because we need to use animation when we're, creating gesture handlers. They sort of go hand in hand. And all these things together basically means Reanimate offers us more power when it comes to animating in React Native. So let's do a quick conceptual overview of Reanimated. This is just barely scratching the surface, but I just want to get enough on the table here so that we know what we're talking about. So Reanimated executes JS on a main thread via these things called worklets, and it minimizes bridge trips while writing JS. So you're basically writing JavaScript functions. They get executed on the main thread, and that's pretty awesome because you can write native logic, logic that's executed natively while writing it in JavaScript. And then you connect to view props and styles via hooks-based API. So it's got a nice hooks-based API that allows you to basically connect to, views and other components. And then you can react to events on the main thread via hooks-based API. So you can kind of interact with native gestures. And we can actually pass messages over the bridge if we need to. So if we have some, logic executing on the native thread, and we need to call back into the JavaScript thread to maybe call a React method or something like that, we can do that. We can kind of pass messages back and forth if we need to, even though that involves, crossing over the bridge, which we try to minimize. But sometimes you can't avoid it, and it offers tools to easily do that. So on to Reanimated's APIs, just again, a very high level overview. First of all, worklets kind of power this whole thing. And a worklet is basically just a JavaScript function that gets executed on the native UI thread. So I have a worklet written here. It's just a normal JavaScript function, clamp, which is a pretty common, animation function where you're clamping a value between a minimum and a maximum. So your value's not going out of those bounds. And the thing that makes this a worklet is literally just this directive up here. You just write this worklet directive. And when you're using Reanimated 2, there's a Babel plugin that basically finds these directives and does some transformation on that and makes it a worklet. So writing JavaScript functions that can be executed on the native side, it's as easy as just throwing this directive at the top. So pretty magical. So moving on, worklets are very powerful, but they're not really the main drivers of this, at least not at first. So one of the beautiful things of this is you can connect to props using this hooks-based API. So we have a use animated style hook that creates a style that's evaluated on the main thread and then updates a view on the native side. So basically you just use this hook, you return a style object, and it can be animated. You can do all the animation stuff inside of this style. And then we have an analog called use animated props. It's like use animated style, but for arbitrary view props. All right, so we also often want to animate values and create animated values. And so Reanimated offers a use shared value hook that creates a shared value. And a shared value is basically, it's sort of like a data structure that can be updated and read from like on the native side as well as the JavaScript side. And updating the value on the native side doesn't require a trip over the bridge. So this offers some really nice performance benefits while still reasoning mostly on the JavaScript side of things. And then there's utility functions like with timing and with spring that allow you to animate a shared value. So this allows you to like apply some easing functions to a shared value and animate things. And that's a really nice API. There's an interpolate method because, you know, an animation library isn't going to be complete unless there's a way to map a shared value and do some linear interpolation. And there's also a use derived value, which allows you to basically create computed values that are derived from other shared values. So there's also some other methods that are similar to these, but this is some core methods here. Now, there's also some nice hooks for responding to gestures. So there's a use animated scroll handler hook, which creates a scroll handler for scrollables like scroll views, flat lists, section lists, things of that sort. So this basically just offers a way to create a scroll handler. And then there's a more general use animated gesture handler hook, which creates a generic gesture handler, which we would probably use with React Native gesture handler. So those two, React Native gesture handler and Reanimated, offer a really nice pair for creating gesture-driven animations. All right, so that's sort of like a high-level overview of Reanimated, but we haven't really looked at any code yet, and I actually want to get into some like real-world examples of like how you're going to integrate this in, and some techniques for doing some animating with Reanimated. So like day-to-day development, some scenarios might be you have a piece of state that changes and you want to notify the user with an animation. So you don't want, you know, things just to abruptly show up. Maybe you want to add some sort of animation. Another scenario, maybe you have an event occurs and you'd like to notify the user. So like maybe the user taps on something and you want to give the user some visual feedback that you're registering their touch. Another scenario would be you're customizing gestures and animations of core React Native components. This is actually really powerful. So you could tap into like a scroll view or a flat list and tweak animations. They already have great gestures and animations built in. Like you can scroll, that's sort of like a gesture and animation combo there. But you could actually tap into that and create your own logic like on top of it, which is really pretty amazing. And then sometimes you like just want to take full control over gestures and animations. You want to like just really write it all from scratch, handle all the gestures, and you want to add animations accordingly. So we are going to look at some examples. So let's dig into some code. First example I have here is basically just a 2-column list of images. And what I've done here is I've added this little activity indicator as the image loads in. These images are coming over the network, and so you can tell they take a little while to load in. So I'll show that one more time. So one of the things I like to do is just throw an activity indicator in while the image is loading. And then you see that the image just shows up. It just like pops into view. So one nice effect, or one nice place to maybe add an animation is so that this image doesn't just like abruptly show up. It maybe fades in, it animates in. We can add a nice little transition there. So I have an image fade in component. The baseline of this is somewhat straightforward. We have an isLoaded piece of state, and then I have an image component, and when it loads, I basically set isLoaded to true. And then I have a little piece of UI here that says, if we're not loaded, show the activity indicator. So nothing too crazy here. But what I want to do is actually add some animation to the image loading in. So to do that, I might use the use animated style hook. So we might just call this animated style. We're going to use an animated style. Use animated style hook. You pass it a function that returns a style object. So one of the things we might do is like, to start, we might just set opacity to 0.5 and pass this through just to see kind of what it does. Probably not going to do much. One of the things we also need to do if we want to pass an animated style to a component is use an animated component. So right now I'm trying to pass an animated style to a regular image component, but I actually need to create an animated image. So I'm going to say animated image. Reanimated offers a create animated component. similar to how React Native's Animated API offers a similar method that allows you to basically pass in a component and then create an animated version of that. So we're actually going to use an animated image here. And so now you can see that my animated style comes in and applies some styles here. Although it's like not very interesting because all I did was set the opacity to 0.5. But what we really want to do is animate this opacity in. So one thing we might do is set the opacity to a with timing. Now this with timing method will create a timing animation. And what we're going to do is if we're loaded, we're going to set the opacity to 1. Otherwise, we're going to set opacity to 0. And we're going to have a duration of, let's just say 400. So what this does under this, like under the hood, which is sort of magical, is if is loaded is true, we have an opacity of 1, else it's 0. And when this is loaded flag switches, Reanimated goes ahead and just animates that value for us. We don't have to create any animated values or shared values or anything like this. Reanimated kind of just handles that under the hood, which is just a pretty nice thing. So let's see if that works. You can start to see these images start to animate in with opacity. And so another thing we might actually do with that is maybe we'll add like a scaling effect to this as well. So we could say, let's add a scale, and we'll do a similar thing of with timing. If we're loaded, let's have a scale of 1. Otherwise, like let's start at maybe 0.7, and we'll do a duration of, I don't know, let's say 300 milliseconds. We'll go ahead and refresh this. Now we should see as the images load, you can see that they actually fade in and they scale up, which is actually a really nice effect. So to add like a opacity and scale animation to these images, we just created an animated style. We use a couple of these easing functions, and Reanimated makes that pretty easy for us. We don't have to do a whole lot of boilerplate. All right, so that's a nice basic example of animating some styles, which is really powerful. So next, let's look at another example. So we're going to look at a custom pressable. So pressable is a relatively new API to React Native that sort of, you can use it to create your own touchables. And so what I did here was actually sort of just replicated the touchable opacity component using the pressable component API. So as I press in on this component, you can see that the opacity drops to 0.5, and as I let out, it changes up. But using the pressable API, you can see that when the pressable is pressed, we immediately apply an opacity of 0.5. So there's no animation here, it just immediately changes the opacity, which is fine. That's sort of like the standard behavior, but we might be thinking, well, maybe we want to animate that opacity to add a nice little effect. So let's go ahead and try that out. Let's start by creating a, let's call this press in progress, and we're going to create a shared value that starts at 0 and then animates to 1 as we press in. So on press in, what we're going to do is actually set the press in progress to a value of 1. And let's do a duration of 200. We're going to make this pretty quick. So whenever we press in on this pressable, we're going to basically animate the press in progress value up to 1. And then when we let go, or when we the press is let up, we're going to animate back down to 0. So as you press in, this shared value animates up to 1, and then you let go, it animates back to 0. And then we can kind of use that to make some animated style. So let's go ahead and actually add an animated style to our pressable. One of the things we're going to need, again, is an animated pressable. If we want to apply an animated style, we need to use an animated component. So let's do reanimated.create animated component. We'll pass in pressable. So we're going to use an animated pressable, and we're going to create an animated style. So let's call this animated style again, and let's use the animated style hook. And we're going to return a function here. So the thing that we actually want to animate is the opacity, and we want to use the press in progress shared value to determine what our opacity is going to be. So we're actually going to interpolate on the press in progress value. As press in progress value varies from 0 to 1, what we want to do is vary the opacity from, let's see, a starting value of 1 down to an ending value of 0.5. And then we can add an extrapolation value. So we're going to do extrapolate.clamp so that we're not extending beyond this output range here. And so what we want to do is just apply. We're going to need to change this a little bit. Let's get rid of our old pressable style here. Let's just add in our animated style that we just created. All right, so now we have this thing animating. And let me slow this down a little bit. Let me make the animation, let's say 700 milliseconds just to make it really drastic, just so that everybody can see. So I press in, we animate the opacity down, and I let out, and the opacity animates back up. We could even probably make this a little more drastic, and let's animate the opacity down to 0.2. So that's like really slow. That's probably too slow to be usable, but just wanted to show everybody what that looks like. So maybe we stick to a duration of 200. So now we have a sort of touchable opacity like touchable, but we're actually animating the opacity instead of just setting it right away. All right, on to another example. Let's look at a on scroll example. Let's look at an example of tapping in to a scroll view. So this is where things get pretty cool. There's a lot of really amazing things you can do with this. I have this, sort of silly example content here where I have this neat horse image and I have a scroll view with just some filler content, nothing useful here. But I just wanted to add some buffer content there. And then I have this like sticky, in quotes, header that sticks at the top of this scroll view. But what I want to do is actually only show that if this big neat horse title has scrolled out of the view. So to do that, basically we need to figure out where this neat horse text lives. And then we need to track the scroll position. And once we've scrolled past it, that's when we show the header. So a couple of things we need to do is we need to create a couple shared values. So let's go ahead. We want to track the scroll position. So let's do scroll y is a use shared value. We'll start at 0. And then we also want to know like where our breakpoint is or like where that title is. I'm going to call it breakpoint. Let's do a shared value. I'm just going to set this to 1000, a pretty big value, but that's going to get updated. So first of all, what we're going to do is basically on this text component that has this neat horse, we can use the on layout prop to figure out like how far down the bottom of that text is within the scroll view. So the breakpoint value is actually going to be the Y value of that text layout plus the height. So that allows us to figure out where basically the bottom of this neat horse title is. And the next thing we want to do is actually create a scroll handler for us to update this scroll Y value. So what we're going to do is create an on scroll method, and we're going to use animated scroll handler. So animated scroll handler gives us a function. We pass it a function with an event payload, and the event payload has basically like how far down we've scrolled. So the scroll Y value is going to be the events.contentOffset.y. So that gives us access to how far down the user has scrolled in this scroll view. And then what we're going to do is actually just attach that scroll handler to the scroll view. So what we're going to do is on scroll, we're going to pass it this on scroll function that we created. So we haven't really done anything yet. We've done some things, but we're not seeing anything show up. What we've done is tracked the scroll progress, and we figured out how far down this neat horse thing is. So what we're going to do is actually add an animated style to this header up here. So let's create an animated header style. We're going to use the animated style hook again. And we're going to return, what we're going to do is just basically change the opacity. And again, we're going to interpolate based on the scroll Y value. Now there's some, it's not magic, but there's some math that's going on here. Basically what we're going to do is we're going to look at the breakpoint value and we're going to back off a little bit. I have a fade offset constant that is something like 50. It's basically like, what's the threshold for making this thing show up? And so as the scroll view Let me format that a little bit. There we go. So what we're looking at here is we're looking at the scroll Y value. And then once the scroll Y value gets inside of this range, and so like once we get close enough to the breakpoint value, what we want to do is actually animate the opacity of this thing from 0 to 1. And we actually want to just clamp this value outside of that range. So let's go ahead and apply that to our header. We have this header thing here, animated header style. Let's attach that on there. So if we reload this thing, now we see that the header is not showing up, which is great. As we scroll down, we'll do it kind of slowly, you can start to see this header starts to fade into the view. So that's pretty neat. The opacity changes once this neat horse title gets close enough to the top, it starts to fade in. And once it's all the way off, we're at an opacity of 1. So that's a neat little effect for actually tapping into a scrollable component, which already has its own gestures and animations, but sort of tapping into it to extend it to do other cool things. All right, we're going to look at one last example. This one, we'll just kind of take a quick look at the code. We won't actually write any. So another thing that we mentioned we might do is actually like take full control over gestures and animations. So a pretty common example of this is like creating a pinch to zoom component. So I have my cute little horse here, and I might go zoom in on its nose by doing a pinch gesture. And then when I let go, we animate it back out to the original zoom. So to do something like this, which seems like it would be sort of complicated, and it's not trivial by any means, but Reanimated makes this pretty approachable. So one of the things we can do is actually wrap our image in a pinch gesture handler, which comes from the React Native gesture handler library. And we can attach a gesture event to that, which we'll look at. And then inside of there, we just create an animated view with an animated style attached to it. So basically what we're going to do is like create an animated style that scales up and maybe shifts around a little bit. And then we've just got our image sitting inside of there. So a couple things that we should look at is the pinch style itself. The actual like animated style for zooming the image up really just has a translate X, a translate Y. And the reason those are there is so that we can maintain the focal point. One of the things you'll notice is like if I pinch in on the horse's eye stays as the focal point of this gesture. So to do that, we actually have to do some math, and we do some translate X and translate Y. And then we're also scaling up by the scale value that we get from pinching. So creating this gesture handler is pretty nice. Reanimated offers a use animated gesture handler hook that gives us information about the, gives us some type information about the gesture we're looking at. And then it allows us to create this context object that allows us to basically persist data between gesture events. And so a common use for this is I have a CX and a CY. And a common use for this is when we start our gesture, this onStart method is called. And we get access to event information, and we get access to the context. And so it's common to do things like tack some information to the context object based on event information. So in this case, we look at the event's focal X. There's actually some math going on here, but we can attach some information to this context object, and then we can use that context object anywhere else within the lifecycle of this gesture, which is really nice. If you've done any animating with React Native's Animated API, sharing like these, like sharing values between life cycles of a gesture becomes really hairy, and you have to create extra values, things like this. So this method of creating a context object is really a nice improvement that comes with Reanimated. So then we have an onActive method that is being called as your pinch gesture is active. We have a little math here. So this is, you could do some matrix multiplication and some transformation logic and stuff like that. And then what we do is basically just update our shared values. So we've got some logic going on there. So as we're pinching, the translate X, translate Y, and scale values are being continuously updated. And then we have an onEnd method, which when the pinch gesture is done, all we're really doing is animating the translate values and the scale values back to their initial values. So we set our translate X and Y back to 0 and our scale value back to 1. So then all we have to do is attach that gesture handler to our pinch gesture handler, and that makes some magic. So that's sort of like the story of creating these custom gestures. If you're using React Native Gesture Handler, you can create nice gesture handler functions and attach it right to your gesture handlers. And it offers a really, really improved experience over React Native's animated API. All right, so that's actually all I have for you today. Just some examples of using Reanimated API in some like real-ish world situations. So I appreciate you checking out this talk. If you want to find me on the internet, you can find me on GitHub or LinkedIn or even email if you're into that.
Thank you, Grant, for this talk. It's been great to see some of the use cases that you have presented, and it's always great to see somebody explaining the advanced features of a animations library. Now, moving on to another speaker, Alexander from Horizon Alpha. He's actually going to talk about something that I have mentioned before once I was introducing Grant to the stage. Alexander is also going to talk about animating everything with 60 frames per second, but he's not only going to talk about Reanimated 2.x, but also about other animation libraries that I have mentioned before. So, for example, Lottie or Animated and other solutions on the market. So you will be able to see how you can utilize different libraries for different use cases to achieve something that is called, like I said, a smooth interface, so our applications feel like they are polished, high quality, and that were made just like native applications that you may see in the App Store. So, Alexander, we just can't wait to see your examples and use cases for all the different animations libraries.
Hi, welcome, or servus as we say in Bavaria here at React Native EU 2021 virtual conference. Thanks for having me again. My name is Alexander and I'm talking about animations today and how to use animations in React Native, that they look beautiful, that they run smooth at 60 frames per second, even on low-end devices. So when we are talking about animations in React Native, we have to keep in mind that the general architecture of React Native can be quite challenging for running smooth animations. There are pretty good solutions out there. I want to talk about 3 of them today. And basically it's the 3 solutions we use regularly in our company when we are working with React Native applications. And I will give a short overview of all these 3 solutions, and I hope every one of you can take something out of this talk. So let's start right away. When we are talking about animations, the first question we have to answer is why are we using animations? Well, first of all, they make our apps look nice, but that's not the main reason. At least it shouldn't be. An animation should always serve any purpose. So at least they should increase the user experience. So for example, we could use an animation to give an advanced feedback for a touch interaction of the user. So when the user, for example, presses a button, which he has to press for at least 3 seconds to trigger any action, we could, for example, fill any bar that the user sees, okay, I have to press, and now the action's triggered. So this is an example which, for what I mean when I say any animation should serve any purpose. Another thing is progress and loading indication. So it's always good to give the user anything he can look at while he's waiting for the content. So progress and loading indication is a good example for an animation or where animations should be used. Also, a lot of apps do use scroll animations at the moment, especially in the header area. So when we scroll, a larger header is scrolled out of sight and a smaller header occurs. And last but not least, animations are a great tool to grab and direct the user's attention to any part of the screen. So when something moves on the screen, the user looks at it. So animations are great for grabbing the user's attention. So basically, you could say animations are an important part of any high-quality app. And since we all want to write high-quality apps in React Native, we should have a look how to make great animations. And to understand how to make great animations, we have to understand the challenge with animations in React Native first. So what's the problem with animation in React Native? I think the part in the middle of the screen is something you all know. It's the general architecture of React Native. So we have this JS thread where we execute our written JS code. And then we have the native thread, which does all the rendering and gets the user interaction. And these threads communicate via this thing called the bridge. And this architecture is fine, but it can become quite a problem when dealing with animations, because when you look at the example on the left-hand side, this is basically an example like I described before. We have an image as a header, and when we scroll, we slightly move the image and the title out of the scroll view, and a small header occurs which stays atop of the image. And when we overscroll, the image gets scaled. It's just normal behavior in an application or in a mobile app. So a lot of apps do this. So it's basically a pretty simple animation. And what's the problem with this simple animation? When you look on the right-hand side, here is described what happens under the hood when we work with the general React Native architecture. We get the on-scroll event and the value of the scroll view every 60 milliseconds, at least if we don't throttle it. And we shouldn't do so, because then the animation would look quite laggy. And every 16 milliseconds, we send the scroll view over the bridge, calculate the new values for our animated components, send these animated values or these values back to the native thread, where the native thread renders the view. So this can become quite a problem, because not every animation is that simple. So there could be some more calculation involved. And when we have a lot of calculation on the JS thread, in the worst case, our JS thread becomes blocked due to all this calculation. And this would mean, on the one hand, we are not able to directly handle any more user input. And on the other hand, it would possibly delay our animation, and we would drop some frames, which then would make the animation look very messy and not that smooth. So there are some solutions to this general problem, and as I said, I will show 3 of them today. But before we dive into the solutions, let me just introduce myself very briefly. My name is Alexander Kuttig. I founded my own software company here in Munich in 2012. I work with React Native since 2016. I also made some small contributions on community projects like Async Storage. By the way, it was a great experience. The guys there were very helpful. So if you never contributed to open source, I can definitely recommend it. So just give it a try, even if it's just a very small contribution. It could help us all. So yeah. Back to me, I'm also an AWS solution architect professional because I needed some knowledge for writing the backends for my app, and AWS is a great solution for that. And I'm also trying to write from time to time on my Medium blog, so if you'd like to, you can follow me there. I'm working at my own company. It's called Horizon Alpha. We are based in Munich. We are 32 people at the moment, and we focus on React and React Native development. And we build cloud-based backends for our React and React Native applications. We are working with AWS, Google Cloud, and Azure. So we're working with all three big cloud providers. Yeah, it's very, very good to work with the cloud providers for backends for our apps because it makes it very easy. Back to the topic. When working with animations, at least when we work with animations in our company, for us, there are three ways to deal with animations. First one is the internal React Native Animated API, which does a good job for simple animations, and we like to work with it a lot. Second one is the great Lottie framework. There are SDKs for native integration, but also React Native Lottie SDK. So it's very simple to use, and I like it a lot. So if you have never heard of it, you will be really surprised how easy it is to integrate animations, smooth animations running at 60 FPS in React Native. And third of all, it's the awesome Reanimated framework, which recently was released in a second version. I love to work with it. If you have never worked with it, you should definitely have a look at it. I think I read in a blog post lately, it's the gold standard of animation, and I couldn't agree more. It's really awesome. But let's start with the internal Animated API. Here we see a very simple example, but it's good to explain how it works. I've taken this from the official React Native documentation, and as I say, it's very easy. So we have this view, which is declared as animated view. This basically means that we can use animated values in the styles of the view. So as you can see here, we have a general style, and then we have this additional style, which gives an opacity value. And this opacity value is one animated value. It's called fade anim. It's just a variable which we define. We can name it like we want. And yeah, we give this value to the opacity. And then to complete what you see on the left side, we have these two buttons. It's the fade in and the fade out button, which calls the fade in and the fade out function. And this is how the declarations look like. So we have this fade anim variable, which basically we work with functional components here. So we store it as a reference, and basically it's an animated value which gets initialized with a 0. And then we have the fade in and fade out function, which uses the animated.timing to change this animated value. So we give the animated.timing the fade animated value and say, okay, please take this value and change it to 1 over the duration of 5 seconds. And what animated timing does is it calculates how the value should be in any frame in this 5 seconds, and then it renders the value, or it passes the value for every frame to native. So basically it's the same for the fade out function, except that we change the value to 0 and that the duration is only 3 seconds. So the fade out is faster than the fade in. Yeah, it's a very basic example, but I think it shows clearly how how animation works and how it is like to work with animated values, because basically all animation works with this animated values. So let's come back to our scroll example from the beginning. Basically, it's the same concept. We have this scrolling value here, and this scrolling value is changed, but it's not changed via an animated timing function, but it's changed due to the animated event function, which we use to kind of couple this scrolling value to the on-scroll event, to the native on-scroll event of the scroll view. So what we are doing is we look at the native event, which we get on scroll, and then we extract this Y value and couple it to the scrolling animated value. What you can see here in the top is basically the image and the view, which is the small header, which occurs. And basically, you can see here the opacity. It takes an interpolated small header opacity variable. We'll have a look at this later. And here we transform the image, right? So we translate it with an interpolated translate value. And we also have an interpolated scale value where we scale the X and Y dimensions of the image. So where does these values come from? Basically, it's simple interpolation. We have the scrolling value, which is our animated value, like in the example before. But now, since we don't only want to use the scrolling value directly, because it goes from 0 to infinity, and we don't want to change any opacity to infinity, we do a simple interpolation. And this interpolate function works very well because we just say, okay, take the scrolling value, and we define an input range and we define an output range for this input range. So basically, when working with this interpolated small header opacity or calculating this interpolated small header opacity, we say, okay, from 0 to 200, please do nothing, stay at 0. And then when changing from 200 to 220, please change from 0 to 1. And what this interpolation does is it calculates the values for the different scroll positions and passes this to native. Same for scale and translate. So when we come back here, you can see this use native driver true. And this really is a very, very important thing, because what this use native driver does is it says, please take all this logic and pass it down to native in one call. So when we are working with use native driver, we change the behavior of the animation from the one we've seen at the beginning to this one. We create the animation rules in our JS thread. We then send this animation rules to native, and the native thread then knows the animation rules, and all calculation and all rendering is done on the native thread. So we don't have this round trip every time on every frame or on every scroll event. We are processing our animation completely into native. And this is really awesome because then we never block our JS thread. We can respond to user interaction. We can use our JS thread as we like. And yeah, that's why you definitely should use native driver when working with the animated API. Well, here we have a little more advanced example. This is taken from an awesome YouTube tutorial from Katalin Miron. I think he spoke here 2 years ago. And as you can see, basically it's also a scroll view or a flat list in this example. And basically it works the same, right? We have this animated event where we have the scroll value. In this case, it's the X value because it's a horizontal scroll view. We also use the native driver. And what's the difference to the example before is that we have the interpolation not on one time in general, but we have the interpolation in every item. So for every item, we have an animated view which has its own interpolated value. And it's very cool because it shows that this use native driver can create very performant animations, even if we have a lot of interpolation in play. And that's only the lower part of the screen here, right? There is some more code for the image in the background and the changing of the images in the background. But just have a look. I've put the Expo snack of Katalin Miron here. Also, he has a lot more YouTube videos on his channel where he talks about using animation with the Animated API. So would definitely recommend it. If you'd like to see some more complex examples, please have a look at this YouTube channel. So summary for Animated. Basically, my tips are use native driver. I would recommend not to use Animated API without using use native driver. Basically, it's just interpolating animated values. It works great with scroll view and flat list because then it's easy just to couple the scroll value to some animated value and then interpolate it. And it's best for simple and easy animations. So now we're coming straight to the limitations because complex animations can become quite confusing. They can become a lot of code and you are able to kind of combine animations. You can run animations in parallel. You can run animations one after another and so on. But they become quite complex and quite confusing very fast. So we in our company use the Animated API for simple use cases and in applications where we only have these simple use cases. Another thing which you have to keep in mind that use native driver is limited to non-layout properties. And this is a very, very large limitation. So things like transform and opacity will work, but all flexbox and position properties will not. So you cannot just say, okay, please change the height with an animated value while using native driver. So this won't work. So after the internal React Native animated solution, I want to show you a framework which I really like and which is the basis of this animation you see on the right. And this framework is called Lottie. So when you look at the animation on the right side, this animation would be quite a lot of code when we would have to script it with Animated or even Reanimated. So all these lines which occur one after another, it would be a lot of work. So that's where Lottie is the ideal library for. Basically, when you look at all these animations, all what they have in common is that they aren't that easy to script. But with Lottie, the code for them basically is all the same. It looks like this. You have a Lottie view and you have a JSON file, which is the resource for your animation. And this really is cool when you have the JSON files. I will show you now later where these JSON files come from. But basically, it's that easy, right? This is the code for all three of the applications, just with different JSON files. We have a container which we center our animation in. Then we have the Lottie view, and we say to the Lottie view, please autoplay, and then it just works. One thing which makes Lottie a lot cooler is that we do have programmatic control over the animation which is defined in the JSON file. So basically, as you can see here, we again have a scroll view where we couple the Y value of the on-scroll event to our scrolling animated value, which is defined here. And then we have an interpolated progress, which we couple, or which we interpolate the scrolling to. And we just say, okay, please, for minus 1000 to 0, go from 1 to 0, and from 0 to 1000, go from 0 to 1. Basically, what we are doing is we use this interpolated progress to say the Lottie view, it should play on scroll. So when we scroll fast, the animation will play fast, and when we scroll slow, the animation will scroll slow. And as you again see, we are using native driver here. So all this takes place in the native or UI thread, and we don't block our JS thread. When you look at the animation here on the left side, you can see it does do nothing when it stays where it is. And when we use the scroll view, it starts animating. And this is really cool because we can have very complex animations in this JSON files, and we can control when it should play, where the progress should be, how fast it should play, and so on. So we have a lot of control over the animation. And where does these animation JSONs come from? Well, basically, they are After Effects animation files. So Adobe After Effects is a program which is used to create animations for videos and for other things. And then there is something called the Body Movement plugin, which creates these JSON files out of the After Effects animations. And this is really cool because when we come to the summary, there is quite a large market for these Lottie files. So there is this lottiefiles.com website, and it has a lot of animations, free animations, paid animations, and you can find animators there which create custom and cool animations in simply no time for your project, and you as a developer don't have to script your animations in your code. You can just work with a professional animator who creates the animation, and then you can use this animation via the Lottie React Native plugin. I put the link in here. And you have at least some control over the animation programmatically. And we use it for avatar animation, we use it for animations which have a lot of components, and we use it for animation where we don't have to be able to change all of the animation in our code, because that's one of the limitations. We don't have full control via code, right? We can say, okay, please play from frame 60 to frame 120, but we can't say, okay, this part of the animation is too large, please make it smaller. That has to be done in After Effects. So one of the limitations is you have no full control via code. The other limitation would be you need to create the animation files either by hiring a designer or animator, or do it yourself with After Effects. After this short introduction to Lottie, I want to talk about the awesome Reanimated 2 framework. It's the third framework we use when we are working with animations, and I think it's the most complete of all. So to understand what happens with Reanimated 2, I took some code from the documentation of the Software Mention page. It's basically, the idea behind Reanimated basically is kind of the same like use native driver, but it's a lot more complete. So what they did while creating React Native animation, they introduced something called worklets. And worklets basically are parts of code which don't run on the JS thread, but it runs on the UI thread. It runs directly on the UI thread. So basically, you can simply put the worklet string in your function, and then when you work with React Native Reanimated, the Reanimated Babel plugin sees, okay, this is code which should be executed on the UI thread, and the Babel plugin transforms the code that is executed on the UI thread. So basically, this is what I just said, right? When we have this scroll view example from before, we have the JS thread where we create the animation rules or we create the worklets. And then we have the native UI animation thread where we have the worklet context. It has its own context on the UI thread. And basically, in this context, the calculation of the animation is done, but again, it's on the UI thread. And it gets even better. So we don't have to write our own worklets. So React Native Reanimated provides us a lot of custom hooks, which we can use to have it a lot simpler to work with Reanimated or with animated values or with code running on the UI thread, so we don't have to define by ourselves what is a worklet and what is not. So we can just have a style variable or a style constant, which we say, okay, use animated style, so make it an animated style, and then we can it runs on the UI thread. Another cool thing is that we can have shared values between our JS context and our JS thread and the native context or the worklet context, I would say. So what that means is when we're in the worklet context, we can synchronously change these shared values. And we are also able, from the JS context, to asynchronously change these values. This is due to the architecture, but it's really cool to be able to communicate from the JS context or JS thread to this native thread, and also be able to synchronously change these shared values inside our worklets. So let's get this. Let's get the pieces together here. So again, we have the scroll view example, and as you can see here, we have a scroll value which is defined as use shared value and which is initialized with 0. And then we have the onScroll, which basically is a function which uses animated scroll handler, which is a part which React Native Reanimated provides us. And again, here we look at the onScroll event and we couple the Y scroll value to our scroll value. And when we are looking at, now I have to go back once. Another cool thing you can see here is that we pass this animated scroll value down to our item component. So we have a lot of items in this scroll view. You can see it's the single items here. And basically, with the scroll value passed down to the item, we can work with this shared value in the item. And that's basically what we're doing here. So this is how the code of the item looks like. And you can see here we have a style here, and we have a title style here. And basically the title style is the style of this text here. And the style is the style of the whole container. And when we go one slide further, here you can see how style and title style are calculated. And basically it looks very similar to how the Animated API works like. We use this use animated style hook, and then we return an object which includes a style, and basically we're using again simple interpolation here. So we are using the animated value which we got passed down to our component, and we say, okay, for this input we're using the index here which we also got passed down to our component. For this index to this index, or this value to this value, please change the size, the height of from minimal height to maximal height. I think it's 200 and 400 pixel here. And when you remember what I said about Animated was that Animated in a native context was limited to transforms and opacity, and we could not work with things like height. Well, the cool thing on Reanimated is here we can. So we are able to transform our flexbox values. When we're coming to the title style here, it's also a use animated style. Only thing is that we only change the opacity here. So as you can see, when we scroll up and down, the opacity of the text below the title here changes. So yeah, basically it's the same what we did in Animated, but in the Reanimated syntax. So this was a kind of a simple example. There are a lot more complex animation possible with Reanimated. There is this very, very cool YouTube channel of William Candillon. He is a magician when it comes to Reanimated and making animations. And on his YouTube channel, he has a series, it's called Can It Be Done in React Native, where he looks at the best animations from any app and builds them in React Native. And most of the time he's using Reanimated and Reanimated 2 now. So the animation you see on the left side here basically is a swiper where you can change the screen by swiping. But it tracks where you swipe and how fast you swipe and things like that. And I included it here just to give you an idea how complex this calculations of such an animation can be. And this part I pasted here on the slide is just a calculation for the wave animation here. So it's just a part of this liquid swipe example. I pasted the link to the full example here. So if you're interested in really cool Reanimated stuff, please check out the YouTube channel, check out the GitHub, which I pasted here. There are a lot of different examples, and you get a very good idea how powerful this Reanimated tool is. So to wrap Reanimated up, we in our company use it for complex animations. We use it we also use it for easy animations when we use it anywhere in our project, because we don't like to use animated and reanimated in the same project because it can get quite confusing. So when we have more complex animation and we integrate Reanimated into the project, we use it for all animations. And my tip definitely is watch the Can It Be Done in React Native series on YouTube. It's awesome. Limitations of Reanimated. Well, basically there are no real limitations except that it can take some time if we want to build really complex animations. So when we compare it to Lottie, where you can use After Effects to create your animations, this can be much faster than to write your animations in code. Well, the advantage in Reanimated is you have full control, but sometimes it's easier to just create the animation in After Effects and you don't need that much control. Then Lottie is the better framework for me. And yeah, that's basically what I said at the last point. Animations have to be implemented by the developer. When you have a larger team where you have someone who really has a talent for cool animations, but he's not a developer, then Lottie is the better framework because he or she can just build the animation in After Effects and then hand it over to the developer. Yeah, to wrap this up, I made a slide with useful links. I think I mentioned most of them. Animated has a very good documentation on the React Native page. I really like the YouTube channel of Catalin Miron. The Lottie library is available on GitHub, or the Lottie React Native plugin is available at GitHub, on GitHub. And on lottifies.com, there are a lot of files and animations for free, and there are also paid animations. So just have a look. Maybe you can find something cool there. Reanimated. There are very good documentation files on the Software Mansion page. They also have some good webinars available there, so you should definitely check it out if you haven't done it already. And again, I can definitely recommend the YouTube channel of William Candillon. It's awesome, and the series Can It Be Done in React Native? It's really awesome. So I want to close my talk with a little quote. It's basically the same which I said at the beginning. Use animations where they improve the user experience of your app. Never use animations just because you think they are cool. So if you're that pumped after this talk now and say, I want to start using animations now and go to lottifies.com, take the best animations, please keep in mind, don't use animations just because they are cool or if they make your app look great. They always should serve a purpose. So that's from my side. Thanks for listening. If you have any questions about the talk or any questions about React Native stuff in general, you can contact me via email or via my LinkedIn account. Thanks again for having me and have a nice conference.
Thank you, Alexander, for this talk. I guess after these two talks, there are no excuses stopping us from building applications that look good and are just beautiful. So the next natural thing is to make our applications secure, and this is what next two speakers are going to be talking about today. The first one, Mateo from Ang, has a rather interesting talk title called Hack Yourself, and in his talk he's going to show us tools and some techniques to test our applications for different security issues, as well as how we can make sure that we don't repeat some of the common mistakes while building React Native applications so that nobody hacks our application in the future. So Mateo, show us how to make it happen and what are the techniques and tools to prevent the issues from happening.
Hello to everyone on the other side of the screen, and thanks to the staff for having me on this new conference edition. My name is Mateo Silguero, I'm 25 years old, and I'm from Buenos Aires, Argentina. I work as the leader of the front-end chapter at ANC, a fintech company based on Argentina too. I'm a mobile security enthusiast, and I'm co-organized a JavaScript meetup called Meetup.js. Before we start, I should read some disclaimers. The first one is don't get the title of this talk wrongly. It's just a play in words. The second is don't try this at home. If you perform some of the following tools or techniques on a third-party application, it could be considered illegal depending on what you do and the country where you live. But I will not be responsible for your action. And the first one is this talk is focused on Android stuff. Then, why should I hack myself? Hacking yourself allows you to explore and detect vulnerabilities on your application before someone else does. When we deploy our app to the stores, it's available for the whole world. And maybe we are exposing API keys, sensitive info, or business logic in the code. Where to start? The first step is to get the artifact we want to hack. It will be an APK for Android or an IPA for iOS. We could generate the artifact from the source, for example, running the gradlu assembly command on the terminal or whatever command you have configured on your project. Or you can even use a web like APK combo to download it if the app was already deployed. This is APK combo. It's a website where you can search for any app on the stores and download its APK. In this case, ours is search for the Twitter app. This is not only for hacking. Some people prefer to use a website like this instead of the official store. The first part of this talk is about secrets. Now that we have our target APK, we can use APK tool for decompile the artifact into the source files. For example, running the D command with the path of the APK we want to decompile. We can see this output on a new folder. And usually on a React Native application, the JavaScript bundle is inside the assets folders like this. Java code is translated to Smalley code, and it is inside the Smalley folder. And native libraries are under the lib folder. Finally, app images and resources are in the res folder, like this. Now we can explore the Android manifest XML and the JavaScript bundle to see if we are leaking any API keys or another sensitive info. For example, in this Android manifest, we are leaking the API key, and someone else can retrieve this information and use it for their own purpose. You can see the value of API key is super strong password, and it is hard-coded into the Android manifest, and the another key is referred to other file. The value of my secret is in the strings.xml file, and there's another XML files that could contain another secrets. You can also read the small code looking for constants like this. We have the debug constant and the version code, etc. We could also find hard-coded info on the JS bundle. If the app uses JS core instead of Hermes, we are gonna see a minified JS file like this. We can use JS Beautify or any other tool to see the bundle in a better way. Then we can inspect the file looking for secrets. In this case, we found a super secret API key variable with the value admin1234. But if Hermes is enabled, the JavaScript code is compiled to bytecode, I mean a binary file. So if we look for our bundle, it would look like something like this. You can see that this is very different from the previous one. All the JS code has disappeared, but an attacker can still retrieve information disassembling the bundle back to Hermes structure set. We can use HVC tool, which can help us to disassembling the bundle to Hermes structure. This is how the instruction file looks like. Now we can look for in this file looking for secrets, and also we can modify this file and assemble again to the bundle. Currently, HVC tool doesn't work on Reanimated 64, but I think it will do in the future. And there are a few tools that can automatically analyze the app, looking for secrets, URLs, and keys, like APK-enum and APK-leaks. This is an example of the output of APK-enum in the terminal. It founds some URLs, but it can also find API keys or secrets, whatever. But also exists MobSF, which is a more complete tool, and it works both with APKs and IPAs. After analysis, it throws a fault report. In the interface of MobSF, you load an APK, and this is the result. It's telling me a lot of the APK information, like the name, the size, how many activities it has, and etc. This is MobSF2. This is a list of the URLs it found on the code, and it can also find Firebase URLs, emails, strings, or hard-coded secrets. Then, how do I protect my secrets and code? For JS code, I highly recommend to use Hermes plus Obfuscator.io, which is a Metro plugin. So the strings will be really hard to read and obfuscate, and our secrets should be protected. Be careful with the rules you enable on Obfuscator.io, because it increases the bundle size. And on the native side, we could use ProGuard, which comes with the React Native on Android, and there are also some paid SDKs. Anyway, as far as you can, avoid managing secrets in your apps or send them via network. They are not completely safe on the client side. The second part of this talk is about user data. Sometimes we have to persist data on the app, like user info, interaction records, and app states. Async storage is the most common library to do this because it was part of the React Native core, but it has one problem. All that you save is persisted on an SQLite database file as plain text. An attacker could retrieve those files and read the saved data. We could simulate this scenario using ADB. ADB stands for Android Debug Bridge, and it comes as part of Android SDK tools, so you probably will have already installed it. ADB helps us to manage both emulator and physical devices, and upload and download files and apps from those devices. We will need a root device or an emulator without play services to get access to apps' private files. For example, we could run the devices command to list all emulator and devices connected to our computer. Then we can run the root command to set a a device as root mode, and then we could run the shell command to get access to that device shell. Into the shell, we could run the ls command, for example, to list the files inside that device. And now we can browse to our app scope, for example, cd data /data/ and the app name. In this example, we have an app called com.rila, and under the databases folder inside com.rila, we could find the RK storage file. This is the default name for async storage library. Then we could exit from ADB shell and run the pull command to download those files into your computer using this command. And now you could open the RK storage database file into any SQLite browser. For example, SQLite browser. Now we can see that we have the super secret key with don't tell anyone value into the database file. To prevent this, there are some alternatives like React Native encrypted storage, or my favorite, MMKB. MMKB is a C++ library developed by Tencent. Tencent is the company behind WeChat and other apps. It is optimized for mobile applications, and there are some wrappers for React Native. For example, React Native MMKB storage and React Native MMKB. This library has some advantages, like it is even faster than async storage. It is 300 times faster on Android and 1,000 times faster on iOS. Also, we could store every type of data, not only strings. And it has an opt-in for data encryption, so we can protect what we are storing. MMKB saves the data into a file too, but if it's encrypted, it cannot be read without the encryption key. This is the path to the default file, MMKB's file, and this is how it looks without encryption. And this is how it looks with encryption. And the third part of the talk is about apps behavior. And we must talk about Frida. Frida is an amazing reverse engineering tool which allows us to hook the code execution from an app. We can define some scripts that could change the app's behavior without modifying the original code. For example, in this case, we could intercept the location module and always return the same coordinates. The use cases for this tool are almost unlimited. For example, in this script, we are hooking the location module and changing the implementation of the getLatitude and getLongitude methods, and always return the same latitude and the same longitude. Frida has also a module called Frida Trace that logs any function call on the native side. For example, we could run this command, Frida Trace. This is a regular expression of what we want to log, and this is the package name. This is an example of the what are we logging. For example, multiset and multi-get methods of the async storage module are logged to the terminal. To use Frida, we will need a root device or to patch the target artifact, and the best way to do it is using Objection. And this is a tutorial on how to do this. Try Frida and see what happens on your app. By doing this, you could identify some backdoors and prevent someone else from bypassing any validation in your workflow inside the application. You could try to prevent someone else from using Frida in your app by blocking root devices and making an integrity check. JailMonkey is an option for React Native for detecting root devices. And integrity check helps us to know if the original artifact was modified. For example, if we patch the artifact. Also, obfuscators made the code harder to read and harder to use Frida. JailMonkey can detect Frida, but Frida could bypass JailMonkey. For example, using this script, we could hook the JailMonkey module and return false for every validation on the library. For example, if it's broken false, could detected false, and so on. This is a guide from I took this script. Okay, and now we have a short demo on how to use Frida. This is a React Native project. I will go to Android folder, run the build command like rootly assemble release. This will take a while. While this is combining, I wrote this as Frida script in Python. This is the JS code we want to run, which hook the JailMonkey implementation. And we can run it using the Python 3 JailMonkey.p. Okay, now we have our APK. I will move it to the root folder, like cp app build outputs APK release app release APK to the root folder. Here. Now we can use, this is the original APK. Now we can use objection to patch the APK and enable Frida on it. So objection patch APK from architecture x86. This is the same of this emulator, and S flag to the path. In this case, release APK. Sorry. Objection will download the Frida gadget and install it to the APK. This could take a while. Okay. Okay, now we have a new APK called apprelease.objection.apk. We can start the original APK to make a test, like adb s emulator version54. This is the ID of this emulator. And install release.apk. And now we have the Relab app installed here. it says true for root device because every emulators are taken by root device. And now we can do the inverse operation like uninstall on reader, and now we can install the patched APK. Okay, we can open it, and this is white because it's waiting for a new Frida connection. Now we can run this script with Python, and now it says false and seems like it. Now we can do a login or whatever we want. This console log is from here. We are hooking the implementation and put all the variables into false. This is the original code. I will commit this to my GitHub account, so you can review it later. And that's the demo. Final thoughts from React Native docs. There's not a bulletproof way to handle security, but you can do your best effort to reduce the possibility of someone else hacks you. Sorry. Next steps, you can keep learning about ethical hacking, practicing on the app of the company you work for, and there are also some hacking labs which give us testing apps to try and learn new tools. For example, these two. And there are other topics to investigate like network traffic proxy, public deep links and activities, etc. This is a complete list of useful links and resources where you can keep learning about the previous topics. And that's all. If you have any question, please contact me on Twitter. And that's all. Muchas gracias.
Thank you, Mateo, for this talk. I guess that was a very important and insightful discussion about security with React Native applications. And now, to make that even more concrete, there is another speaker, Thor, from Stripe, and he's going to talk about some of their real-life use cases with security in React Native. Now, if you don't know, Stripe is one of the largest, I guess, these days, payment providers, and they are actually using React Native for accepting these payments. Actually, they have React Native SDK that you can use if you are building React Native application to accept that kind of data so that your users can pay for certain things through your app. So they must have solved the security in the best way on the market, I guess, because in banking this is extremely important. So I'm just really excited to listen about their experiences, what they were looking after, and how did they make sure that there is no issues whatsoever within their SDK. So Thor, I just can't wait, and we are all looking to listen about your real life experience as far as security with React Native.
Hello everyone, my name is Thor. I'm a developer advocate at Stripe, and today I'm going to show you the money, or at least how to securely accept payments in your React Native apps. Now, if you want to follow along in the slides, you can find them at thor.news/React Native EU 21. The great thing is when you have the slides, all the visuals, you can click on them and find the relevant docs or code snippets. Now, we recently shipped our official Stripe React Native SDK. And before we take a look behind the scenes, let's kick things off with a demo of our new mobile payment sheet, implementing it into an Expo app. Now, the payment sheet is this overlay that comes up and takes care of everything related to payments for you. So it securely collects card details, it has support for Apple Pay and Google Pay, and you can also add saving card details for future use so your customers can check out even faster. Now, in order to enable this functionality, we need a server-side component. I've drawn that up here. So if we want to store the details on our customer, we need to retrieve our customer. Here in the demo, we're just getting the latest customer from our list. Of course, in your application, do make sure that you retrieve the authenticated customer and store the details there. Next, we will need to create a short-lived ephemeral key. So this key is what we provide to our payment sheet, so it can load the payment methods from our customer object, as well as add new payment methods to it. And then lastly, we need a payment intent. So this is our actual payment object that tracks things like the amount, the currency, and all those details. And so this endpoint we have here on our server just returns our payment intent client secret to our Expo app, as well as our ephemeral key secret, and then lastly the customer ID for our authenticated customer. So now I have this server running here locally on localhost, and then I have an Expo app just running here on the iPhone 12 simulator. Now, my Expo app is just a simple TypeScript Expo template here with some React navigation. And so here what we can see is our single step. And so I've just added some text here for some test cards that we can use in our example. I have some styles here, and then I have a little fetch helper to fetch the details from our server that I just mentioned. So the client secret, the ephemeral key, and our customer ID. Okay, so to get things started, let's actually install our Stripe React Native library. And so to do that, let's use Expo install. Please make sure to use Expo install, because that actually installs the corresponding version of the SDK that works with your Expo SDK. So we say Expo install Stripe React Native. And then as you can see here, it now finds the version that is supported for our Expo SDK version. So in SDK 42, we use the Stripe React Native library 014. And so now that is installed. So let's import this, and we can import from our @Stripe React Native. And so we have a convenient hook here called use Stripe that exports all our methods that we need. And so let's go ahead and get our methods from use Stripe. And we can, since we're using TypeScript here, we can get all the type definitions and all the functions. So we need the payment sheet related ones. So that's init payment sheet and then present payment sheet. So these are the two that we need. And then we also have a state variable here for our loading state. Okay, so now let's go ahead and initialize our payment sheet. And we're just going to do this on page load in your app. Basically, you want to create your payment intent when kind of the last step of the checkout, when you know the total amount and all those details. So here, for convenience, we're just going to do that in our use effect. So when our single step view here is loaded, and then we're just going to create an async. So because it's an async method, we need to create a new one here. So we'll just create an init function. First of all, we'll set our loading to true, so we can disable our button while we're loading our details here. And then we're getting our details from our fetch payment sheet, fetch payment sheet params. And so this is our payment intent client secret, our customer ephemeral key secret, as well as our customer ID. Here we are. So we're fetching those from the backend, and then we are initializing our payment sheet. So let's do that. and we can say so init payment sheet. And there's a couple things we need to provide. So first of all is the customer ID, and so that's our customer from above. Then we will need the customer thermal key secret. So we have that above. We need our payment intent client secret. And then we can specify if we want a custom flow. A custom flow allows us to separate out the selection of the payment method and the confirmation of the payment. So let's just here say we'll want to do that all in one step. So we'll say custom flow false. We provide a merchant display name. So let's just say React Native EU 2021. And then we're also we want Apple Pay enabled, so we'll say Apple Pay true here. And if we say Apple Pay true, we need to provide a couple more things. We need to provide our merchant country code. Let's just set that to US for this example. And then that should be it. So with this, we can now init our payment sheet, and in it, the payment sheet, we have an error. In case there is an error, we can say, first of all, once that resolves, we say set loading is false, and then we just check if we have an error. We say if error, we will just for now console log the error, see what's going on. Okay, so now we have our init method set up to init our payment sheet. And so lastly, we'll just need to call this init. Fabulous. So now we've got that set up. And then in the next step, we'll want a start checkout method. So we'll say start checkout. So that's when our customer hits the checkout button. So it's an async method that we need again. And we'll just say, again, set loading to true. And now we can start our, so the second step is to present our payment sheet. And here we don't need to provide because we provided all the necessary parameters in our initialization above. And again, here we can get an error. And let's say if we have an error, then we want to alert with an error method message. So let's say first thing is our error code. We'll just put in the error.code, and we can see that there is a bunch of things that might be available on the error to inspect. So we'll say the code, and then we'll just output the error message. But otherwise, if we don't have an error, we can say alert success. And we can say the payment was confirmed successfully. Yay. Okay, and so lastly, we'll just need a button to start our checkout. So let's add a simple button here. Maybe we'll want to disable the button if we're loading. So when we're loading, the button is disabled, and then we want to also give it a title, and we'll just set the title to well, actually we can say while we're loading, we'll just set the text to loading, and otherwise we'll say checkout. Great, and so now we're loading, and now it says checkout, and then we'll need an on press, and that is just our start checkout. Okay, so now that we've got our parameters loaded, we can hit the checkout button, and we can see here we can use Apple Pay, which then brings up the Apple Pay sheet, and then the billing details are collected via Apple Pay. But now let's actually use our trusty 4242 card number here, and we'll provide our billing details. And then here is the checkbox, because we've provided the customer ID and the ephemeral key, so we can save this card for future payments with React Native EU. Let's do that. Let's save that card, and we're processing, and yay, this, the payment was confirmed successfully. Great, so now let's actually go ahead and have a look at this on an Android device. So we're opening the Android simulator here. There we are. Let's go to our single step. Let's wait for the parameters to be loaded, and we check out. And now we can see that because we're using the same customer ID, we can see the payment method has been stored on the customer, and now they just have to hit pay, and they can also pay on Android. Fabulous. So now that we know how to process payments in our apps with Stripe, let's understand when we can use Stripe. Because if you're selling digital products or services within your app, so for example, subscriptions or in-game currencies, game levels, access to premium content, or unlocking a full version of the app, then you must use the App Store's in-app purchase APIs. Please make sure that you understand for your use case. So do check out, I've linked the Apple and Google guidelines for you with more information. But for other scenarios, so for example, if you're selling physical goods or physical services, you can use this SDK to process payments via Stripe. Great, so now we know how and when we can use Stripe. So let's have a quick look behind the scenes. And so here we have what I like to call the layer cake. The layer cake that is the Stripe React Native SDK. And now I'm not the artist behind this great visual. You will see actually the original I made, but my fabulous colleague Chris Tragonas has made this great visual for us. So you can see the foundation, the bottom layer of the cake are our Stripe Android and iOS native SDKs. Then on top of that, we have what I call the native unification code or glue code that is entailed within our Stripe React Native library. And then we have the React Native bridge. And on top of that, we have our native Stripe SDK TypeScript module. So that is what facilitates the communication between the native code and the JavaScript bridge. So all of that happens in there. And then our top layer, we have our native UI components, so our card field, our card form, our Apple and Google Pay buttons, all of those components. And then the icing on the cake, we have our hooks for convenience. And so now let's have a quick look at what I had drawn up. Definitely not as tasty, but yeah, here to recap. So the foundation layer are our native mobile SDKs. Then we have our native unification code and our native Stripe SDK TypeScript module that facilitates the communication over the React Native bridge. So all of that put together is what we consider the native module. And then on top of that, we have some native UI components and our developer experience sugar, the hooks, the icing on the cake. Great, so now let's actually dig into these layers. So first of all, why are we using Stripe's native mobile SDKs? You know, you could say, hey, we're just collecting some data in our app and then sending that to an API. What's the big fuzz? But especially when you're dealing with credit card data, there is a thing called PCI compliance, and in Europe as well, there's strong customer authentication. And so with these native Stripe SDKs, so Stripe's native mobile SDKs, the Android and iOS SDKs, are developed with all these considerations in mind. And so by utilizing these as the foundation for our React Native library, we can make sure we give you the easiest way to PCI compliance and strong customer authentication. Because the native mobile SDKs implement everything in a secure manner and with the new 3D Secure version 2 authentication standard, which is actually very difficult to achieve in a non-native environment. So that's why we're using our native mobile SDKs as the foundation for our cake. Now let's dig into the native module. So we're using React Native's native modules. So on iOS, we've written this in Swift. So here with the gray background, and again, as mentioned, all these visuals are links. So when you have the slides open, you can click on it and you can get to the actual open source code for it. And so we've implemented it in Swift. You can see here we have our Objective-C identifiers to make sure everything is exposed to the Objective-C runtime. And then we have our Stripe SDK.m, so our implementation, which actually then exports the module, the Stripe SDK module. Very similar on Android, we are implementing our React module with implementing the React context-based Java module, and it's called Stripe SDK. And then our Stripe native SDK TypeScript module. So we have all our types defined in there, and then what we're doing is we're getting our Stripe SDK module via the React native modules, and then we're just exporting it with typecasting so we can make sure we have the types available when you're developing in TypeScript and JavaScript for your code completion and all that convenience. Then next, our native UI components. So as I mentioned, when you're collecting card details, you really want to make sure you're doing that securely and you get the easiest way to prove your PCI compliance. And so that's why we're exposing these native UI components. Again, on iOS, we are written it in Swift, and then we have the implementation. Now, the interesting thing with this is actually the native components handle all the card information, and we don't actually expose the card information to the JavaScript bridge. So all of that is handled on the native side. We're really just storing a reference to our native UI components, and then we are extracting the card information at that point, and it goes directly from native component to the Stripe API. So that's really how we can ensure the security of this. And then here you can see this is our card field component. So we're utilizing require native component in our React Native component implementation. And lastly, we have our developer experience sugar, the icing as the icing on the cake, as I mentioned. So hooks for convenience, really, they are just there for convenience. So if you have an older React application that you're maybe migrating over, you can import all of the methods that you need as top-level imports. So we're exporting all functions that you need as top-level exports as well. And so the hooks really give you a little bit more convenience. So you can see here, for example, the use confirm payment hook also exposes a loading state variable. And so you don't have to do that yourself. You can just use that loading variable to, for example, disable your button while the payment is being confirmed. And so that's really just to give you a nicer developer experience. Now, next, you saw in the demo that their Stripe React Native SDK works with Expo. And this was really important for us because Expo is the easiest way to get started with React Native, and especially with the Expo Go client, it's such a delightful experience. And so we actually partnered up with the Expo team to make this experience work with the Stripe React Native SDK. And so we're happy to say that since Expo SDK 42, and what a fantastic coincidence, 42, great number. So the Stripe React Native SDK is available with Expo and the Expo Go client. And as mentioned, it's important that you use Expo install so that you install the corresponding version for your Expo SDK. And then even another icing on the cake we have is the config plugin with Expo. So that gives you a simplified setup, especially for Apple Pay and Google Pay, where you have to add permissions and configure things. And so by utilizing the config plugin, we'll take care of that in the background. And if you click on the big 42 here, you can get to the Expo blog post about the SDK 42 release and find some more information there. And now I just want to take some time and really say a big thank you. It takes a village. And so a big thank you to the whole React Native community, and especially to Callstack and Expo for their major contributions to this SDK. We had the SDK in a private beta for a while, and we really had some members from the community provide feedback and write up issues, and that really helped us to make sure we are providing a good developer experience. So big thank you to all of you. We really appreciate it, and we're super happy that we're able to develop this as an open source project. Okay, now that's it from me. Thanks so much for tuning in. If you have any questions, any feedback issues on the library, please to go to our open source project on GitHub and file the relevant issue there. You can also reach us on Twitter, Stripe Dev. You will always find someone to answer your questions, or you can also find me at Thor Web Dev. Thanks so much for tuning in, and see you on the interwebs.
Thank you very much, Thor, for this talk. It always makes me happy to see companies like Stripe, bigger enterprises, showing that you can do secure applications with React Native. And I guess after your talk and after Mateo's talk, nobody ever in the world can say that React Native is just not secure enough for any kind of application, whether it's banking or any other industry. Now, I guess this is a good moment to wrap it up and move on to a second break today. This time slightly longer, so we can all have some meal, maybe lunch, and prepare for another series of talks that we have for you today. So before you go to enjoy your break, just make sure to join our Discord channel if you haven't done it yet, and ask some questions around. We will be answering them on our podcast. You can also ask some of the questions directly to the speakers, and just have fun together with other people so that it doesn't feel like you're just watching it all alone. So I guess that's it from me, and see you once again in half an hour. This conference is brought to you by Callstack, React and React Native development experts.
Hello.
Hello, I'm Mike, CTO and co-founder at Callstack, and today I'm looking for the best React Native developers to join my team. Besides working on high-end software used by millions, we also contribute to many open source projects such as React Native Paper, React Native Testing Library, or Repack. And so you will have an opportunity to develop your skills and knowledge within these projects, as well as move your own ideas into life by taking part in our R&D program. We are a great team full of people crazy about React Native technology, and we can't wait to share our knowledge and description with you. Trust me, it's great to be part of such a team. So don't wait anymore, join us, check out the job description in the link below and apply, and I'm hoping to see you soon in our Callstack office or maybe remotely depending on your location. Bye bye.
Wake up in Wrocław, get up and get at 'em. React Native EU is on and it's happening. check in to check up on all of the latest news and strategy. Man, it's kind of the greatest.
Welcome to React Native EU 2019.
Keynotes that unlock a new world of insight. Lightning talks this cutting edge? It really seems so right. Networking with everyone in the React Native community, from the thinkers to the linkers, we're all here in unity. Q&As that dive deep into code DNA, and it's all covered here in only 2 days?
Especially when it comes to trouble.
After the last session, we're gonna party, okay? Food, drinks with good vibes and dope karaoke. High fives all around, it was good to be here. Can't wait till the next one. We'll see you next year.
This conference is brought to you by Callstack, React and React Native development experts.
Hello.
Hello, I'm Mike, CTO and co-founder at Callstack, and today I'm looking for the best React Native developers to join my team. Besides working on high-end software used by millions, we also contribute to many open source projects such as React Native Paper, React Native Testing Library, or Repack. And so you will have an opportunity to develop your skills and knowledge within these projects, as well as move your own ideas into life by taking part in our R&D program. We are a great team full of people crazy about React Native technology, and we can't wait to share our knowledge and description with you. Trust me, it's great to be part of such a team. So don't wait anymore, join us, check out the job description in the link below and apply, and I'm hoping to see you soon in our Callstack office or maybe remotely depending on your location. Bye bye.
Wake up in Wrocław, get up and get at 'em. React Native EU is on and it's happening. Check in to check up on all of the latest news and strategy. Man, it's kind of the greatest.
Welcome to React Native EU 2019.
Keynotes that unlock a new world of insight. Lightning talks this cutting edge? It really seems so right. Networking with everyone in the React Native community, from the thinkers to the linkers, we're all here in unity. Q&As that dive deep into code DNA, and it's all covered here in only 2 days?
Especially when it comes to trouble.
After the last session, we're gonna party, okay? Food, drinks with good vibes and dope karaoke. High fives all around. It was good to be here. Can't wait till the next one. We'll see you next year.
This conference is brought to you by Callstack, React and React Native development experts. Welcome back after break, and we are here for another 4 talks. 2 of them will be about testing, so something very important when it comes to building React Native applications, and I guess no conference in the world can be done without talks about testing, as well as 2 other talks about communication, so something real-time or voice-related. We will all hear about that just in a second, but starting with the first talk, we have Louis from BAM, and he's going to talk about test-driven development with React Native using React Native testing library, so I guess one of the most popular testing libraries out there. Now, test-driven development is one of these concepts that are sometimes very, very useful, but you need to understand them right and you need to know how to utilize them in real life. So I'm really excited for Louis to show us how to do it the right way and how to do it in a way that we can test the application, make our developer experience faster, release without issues, as opposed to making our life harder. So Louis, we are here waiting for you to show us how to test React Native applications the right way.
My name is Louis Zawadzki, and I hope my pronunciation is correct, as I'm actually French and work for BAM, which is a Paris-based mobile development agency. Today, I'm going to talk about TDD and React Native. So, you might be thinking different things about this topic already. You might be thinking, well, I don't know what TDD is, or I hate TDD, which is a fairly common thought actually, or I don't know how to apply it to React Native. So if you're thinking one of these, I hope there will be something for you in this talk. But first, I want to tell you another story. A story about something called Dr. Shotgun. A few months ago, the COVID vaccination was made available to anyone above 18 in France. To book a slot, you had to check regularly on some websites. Then when one slot was available, you had to click through the interface and pray that you were the fastest to get it. So, what did French developers do? They created a script so that they didn't have to check the website and they were going to be fastest anyway. One of the scripts was called Dr. Shotgun. So when that happened, I thought, well, as developers, maybe we have some kinds of superpowers, you know? Well, let's see how we do every day at work. Let's take, for example, a specimen of the React Native developers. Let's see what they do in their everyday work. First, we see them coding on their laptop. They look happy and very focused. Then, they open the simulator or install the app on their phone and they try the feature. And most of the time, it just does not work as expected. So, our developer, who has tremendous determination, is now going to make use of logs and breakpoints to try to understand what the heck is going on here. Then they rebuild, they rerun several times before everything works fine. Each of these iterations can cost 2 minutes or even more, so it's a rather painful process. And it's not the end of the story for our developer, as they have to write a non-regression test to prevent other developers, including themselves, from breaking the app in the future. So, it looks like we don't have much superpowers and we spend a lot of time clicking in real life. Okay, so I think now it's a good time to introduce my topic. I'm going to briefly explain what TDD is before going further, so we make sure we're all on the same page. TDD stands for Test-Driven Development. It's a development technique from extreme programming that can be described as 3 phases. First, when you want to add a feature, you have to write a failing test. It's going to be printed in red, so that's why we call it the red phase. Then, you write the code needed to make the test pass. That's the green phase. But you're doing it as quick as possible, and that's why you need a third phase, which is called the refactoring phase, where we clean the code before going on to the next feature. Okay, let's go back to our developer story and see what changes when they use TDD. So now, instead of writing the test at the end, when they've already been through a lot of pain, they write it first. And then they can iterate until the test works, which is usually much faster than using a device, because you get a much faster feedback. And finally, they check on the device, and this time it works most of the times. So, TDD sounds like a good idea, and you're probably thinking, well, that's in theory, right? Otherwise, everybody would be doing it. 2 years ago, I thought the same, and I wanted to be sure. So I challenged myself to do 100% TDD for 2 weeks. But I struggled at first a lot because I didn't know which tests to write before starting my feature. And to earn you some time, I'm going to show you how to do it. First, let me introduce the app we're working on. It's a Hacker News clone. Hacker News is a website that shows links of tech articles of interest. And I'm going to show you how to develop in TDD 2 features that are, I believe, quite representative of any React Native application. So first, we can see our application here, that you already have a list of top stories, which are ranked by a mysterious algorithm. And on top, I have a button that enables me to change between top and new stories, which are the newest stories. So right now, when I click on the button, its title changes, but that's all. And what we're going to do here is we're gonna fetch the new stories when we click on the button and display them. So let's have a look at the code before starting. What we have is a page component which contains 2 states, one with the list of items and the other one with the list with the type of stories, which is either top or new. Then we have a toggle stories type function that toggles between top and new the state of the stories type, and right now it's just used to get the title of the button, which is computed in a little function here. Then we have a use effect that's called at the beginning, at the first render of our component, and that gets the list of news items. Actually, it only gets the top stories. So what it does, it's defined here, it fetches the top stories, and it gets all the IDs of the top stories, and we set the news items to the first 20 IDs. And then we use a flat list in which we render our news list item, which is a component that we're going to see in a few seconds. And we just pass to this component the ID of the item. Now, in this component, what do we have? We have a state that we initialize to null that contains the item. And in a use effect, similarly to what we've done before, we get the item. So what this function does is that it fetches the item on the Hacker News API. It returns this it parses the JSON and sets the item. So this is the interface of the item, and you can see here we display some information. You can see here, for example, the title, the host name, a number of points, the author, and the number of comments. And we have a test file, and in this test file what we have is one test in which we mock the top stories API and the items. So these functions, I made them myself, and what they do is that they actually use knock, which is a handy package for mocking API calls. And so here we mock the top stories API and we return the list. And here for one item, we mock the API for the ID and we return a fake item in which we only change the title here. So in our test, we render the page and then we check that the 2 titles that we have passed as arguments to the mocks are displayed. Then we have a small test on the type switch that checks that the title changes. And finally, we have a snapshot to cover our back whenever we change some components, but we're going to go back to that later. Okay, so now what I want to do is to fetch new stories when I click on the button, and the new stories and not the top stories. So what I'm going to do, before pressing the button, I'm going to do a bit of setup here. I'm going to mock new stories. I need to create that function later. And what I'm going to do is that similarly to this one, I'll pass let's say two different IDs. And then I'm gonna mock these two items differently. So with a different title. So here I say some new story. And then another story called TDD is my best friend. Okay, so now when I click on the button, so it's going to be asynchronous, so I'm going to need a wait for from React Native testing library. And then I'm just going to check that those two titles are displayed on my application. Now for the mock new stories list, I'm going to copy and change slightly the mock top stories list with the new stories API, which is this one. Okay, so now I'm going to show here my tests are actually running. And we can see that it's hanging probably because it can't find the components we're looking for. Here, if we see, it was expected to see some new story, but it didn't receive anything, and that's what we expected. So we're done with the red phase, and now we're going to do the green phase. So let's go back to our component, and here what I want to do is to call a new route and to set the items whenever the stories type changes. So what I'm going to do here is I'm going to simply pass the stories type to the use effect, pass it as an argument here to get news items. Okay, here I add it, and I'm going to already say that it's either top or new. Okay, and now I'm going to change here my URL. So in the green phase, I have to go as quick as possible. So I'm just going to here say end of URL, and if stories type equals top, then it's going to be top stories. Otherwise, it's going to be new stories. Okay, and now here I just change this so I can simply put here my end of URL. Okay, so I think that should do it. Here it's complaining because I don't know, maybe it's a bit slow. Oh no, here just made a mistake. Up, should be better. Okay, now it should be compiling. So let's check our tests. So as I'm recording, the tests are a bit slow, and now I see that I have a change in my snapshot, which is a good sign, and now it displays some new story, and TDD is my best friend in my final snapshot. That's actually what I expected, so I'm good. I'm gonna update the snapshot, and now I'm gonna check on the real app whether it's working or not. So I'm just gonna refresh and see. So here I see my top stories, and if I click on show new stories, there's a bug. That's interesting because I didn't foresee that. That actually it says here undefined is not an object, get host from URL. So that's one of the cases where you can see that something is not working. But now I know that it's not my code that's supposed to fetch the items that's faulty, but rather it's something that I didn't see. That here I have a function that parses the host to display it, and sometimes the URL is not defined. So here what I'm going to do is I'm going to say this URL can be undefined in my interface, and then I'm going to say, okay, if my URL is defined, I return this. Otherwise, I return an empty string. And now I refresh. Let's see what happens. I show my new stories. I see here this one, the third one, didn't have a URL, and that's why it was failing. So at this point, I'm going to be honest, I should have written a test for that. I could have actually written a test for this little function here, but as I have limited time, I didn't do that. I've skipped refactoring so we can focus on another example. Now that we've seen how to write tests for an API call, I'd like to show you how to do TDD when you want to add some design to your app. So let's say that when I click on one of the articles, I'd like it to open on Safari, and if I've clicked on it and I go back to my app, I'd like to see the title grayed out so I know which one I've already read. So it's design stuff, and it's usually something that we think it's impossible to do in TDD. Well, of course, you could use visual regression tools. Maybe someone has presented some of them at the conference, but personally, I don't use them because it takes some time for this test to run, and there needs to be a lot of conditions for it to work. First, you have to have pixel perfect mockups, then you have to be aiming at pixel perfect, and the data on your design has to make sense. So if you want to use TDD with visual regression tools, you need to have a lot of conditions. Okay, but our goal is to be test-driven here. So here's how I apply a TDD mindset when designing components. The only tests I write that can catch a design bug are snapshot tests. I tend to use them very sparingly compared to a few years ago, as they are not very easy to debug or understand, and they can break easily. Personally, I like to do one per page. As you can see here, I have a final snapshot at the end, so I know which page to check on my simulator when I change a component and I see the snapshot is broken. Now, I can't really write the snapshot before coding, right? But I can do two things to make the snapshot update actually much faster. First, I can check if there's already a snapshot in place, so I don't have to find out later how to mock my data and to update my test so that it is covered by the snapshot. Two, I can find out which existing snapshots are supposed to break, so that when I'm happy with my design, I can quickly update my snapshots and I know exactly which changes I am expecting. If there is a change in one of the snapshots that I did not anticipate, and right away I have to check if this page is still okay. So here it is not so much test-driven development in the sense of writing the test first, but TDD in the sense that you know exactly which output you're expecting from your tests, and you don't have much thinking to do after the feature is done. So, how are we going to do it? So I'm going to simulate that I'm clicking on my TDD is my best friend item. So I'm just going to add some context here. So say link press. Okay, so I'm going to rename this story, and I'm going to simply get by text TDD is my best friend. Now, when I save this, I expect my test to still pass. So I'm just gonna open up the terminal for a second. And now what I'm gonna do while my tests are running, I'm gonna simply change here. I'm gonna add isRed boolean. Let's do a flag. isRed set isRed. Which is going to be a use state of a boolean initialized to false. Okay, and now what I'm going to do is that on the onPress here, I'm going to set isRed to true. And then I'll change the style here of my component, of my title, so it's this one. So I'm going to change it here. So what I'm going to say is that if red is true, I'm going to add to this component color. So let's say blue, so that it's going to be more visible to you. Okay. Sorry, so it's not red, it's red. So I'm going to run my tests. And now what I expect are two things. So now I'm expecting that my snapshot for the first of the components that I've rendered displays an array here of the style, the previous style, and then false. And for the second one, it displays the previous style and the color blue. So let's have a look at how the snapshot is failing. And what it's saying is that, okay, I have one that turns from an object, one style turned from an object to an array to which I did the color blue, and the other one turned from an object to an array with false, which is what I expected. So now I can update the snapshot, I can refresh my app and check if everything works for real. So here's my app, and when I click on one of the links, the title turns blue. So I'd also like to show you how we can open the link in the browser, because I think it's interesting as well. So here, after I press the button, I'm going to expect linking, which is the React Native library that opens link, that open URL to have been called with, and now I'm going to pass it the URL of my item, which is actually the same for every item, but it's not really a problem. Okay, so now I save my tests, and now my tests are expected to fail. And here what I can do is I can, in my component, do linking dot open URL with the item dot URL. Okay, so now TypeScript is complaining that it can be undefined. So here I'm gonna just wrap it into an if condition. So obviously I should be writing a test for that, but unfortunately I don't have very much time for this demo. Okay, so let's just check if our tests have failed. So yeah, they failed because linking.openURL has not been called. And I'm gonna save this, change, and now I expect my test to pass. Okay, on another note, while I'm waiting for my tests, maybe you should add some accessibility hints here to see that your title has been read, because it's going to be nicer to your users, and actually we wouldn't depend on snapshots. But for the example of adding some design, I thought it was kind of easy. If you like the demo and want to know more about it, I have written an article covering more cases, and I should be dropping the link in the YouTube chat section or on Twitter after the conference. I told you I started a 2 weeks TDD challenge, but I did not manage to do 100% TDD on the first day. So here's how I did it and how you can do it too. First, before going to TDD, you have to train at two things. The first one is to train at refactoring. It's a major part of TDD that's easy to overlook, and it's easy to mess it up too. There are a ton of books and websites about refactoring. My favorite ones are refactoring.guru and the Martin Fowler book, so check them out if you want to know more about it. Then you should also know how to use Jest and React Native testing library before starting TDD, otherwise it's going to be a lot to learn at once. Then, when you want to apply TDD, you should start by doing it where you have confidence in your test, where you already know how to test the feature. That way, in the win phase, if your test is still not passing, you're sure that it's not because of your test and it's a real bug. Otherwise, it's going to cost you a lot of time. Then, for every case where you don't feel confident about your testing, learn how to write the test afterwards, so you'll feel confident next time and you know how to write the test. And if you apply this, you get closer and closer to 100% TDD. And as I personally started to apply TDD more and more, I discovered it was bringing me more and a lot more than just faster delivery. The first thing I gained was a better knowledge of my testing tools, Jest and React Native testing library in particular. And as my tests were becoming more important, my tests files became first-class code to me. That means I was paying more attention on how I split them, and I started to write custom functions and extract some of them just for my tests. And as a consequence, they became easier to maintain and a lot simpler to write. And I also increased my test coverage. And by that, I mean I really increased the number of features that were covered by my tests. And finally, in many cases, I figured out that my initial architecture or technical solution was not good enough to write simple tests. And usually, by making more testable, it was actually easier to understand and change later the code. And that's what makes me think that TDD makes me have a better architecture. So, I hope I've changed a bit of your opinions. So if you didn't know what TDD was when you started this talk, I hope now you know what it is and you know how to get started. If you were a bit skeptical about TDD, I hope you may want to give it a try, or at least to discuss it with some colleagues, or you can discuss with me on Twitter if you like. And if you didn't know how to do it, I hope I've given you all the keys, or at least some of the keys, to get started. Thank you very much.
Thank you very much for this talk. I guess now we have no excuses to not test our applications with React Native Testing Library. We all know what TDD is and how to do it the right way, so I guess we just all need to start doing it if we haven't done it yet. Now moving on to another speaker, Lars, who is a freelancer. He's going to talk about testing your applications when it comes down to a Bluetooth device. Now, as you know, the world is changing and there is more and more third-party devices that your applications need to integrate to. And Bluetooth devices are, I guess, the most popular ones. Now, testing Bluetooth devices can be rather hard, and as you know, end-to-end tests tend to be often quite flaky. So Lars today is going to tell us about the library he created for something called mock testing, which lets you mock the whole traffic with your Bluetooth device and actually test it with Jest, which I guess saves you minutes to even hours depending on the number of test cases that you have. So this all sounds super exciting, I guess even more for those of you that are working with third-party devices. So Lars, just show us what you've been working on and how we can make sure that we test it all when it comes to Bluetooth communication.
Hello, my name is Lars Thorup. I will talk with you about how I have done integration testing, and really fast integration testing for React Native apps, specifically when you are testing against a Bluetooth device that you're controlling with your app. I am a software engineer from Denmark, working as working freelance and doing open source development. For the agenda, I will start by talking about Soundbox, where I did this work. I did this work in collaboration with Soundbox, and talk about how we came to the tool that we have developed here. Go into more details about when you want to test against a Bluetooth device. What is a good way to do that? You can do end-to-end testing, which covers a lot of good things, but they are also quite slow and fragile. And you can also do classic unit testing, where you write mocks for your Bluetooth messages. You write those by hand, but that's not good either. And this talk will focus on how you can do mock recording, which will give us really fast and really robust, but true integration testing. And you will see some demos along the way. But as you can see here, you can do full integration testing in a few hundred milliseconds, which is really nice. So I started last year working with Soundbox, and Soundbox is a Danish company producing really awesome Bluetooth speakers that you can carry around with you. They are able to play really loud. You can have a small party going on, or maybe even a small festival using these Soundboxes. And they come with a number of, in addition to the very good sound they have, they come with a number of of interesting features from an app perspective. So you control the speaker with an app on your phone, and you can control things like equalizer settings, and you can lock your speaker if you don't want anybody else to play on your speaker. And one of the interesting features also is that if you have more than one soundbox, you can connect them together, join them together, and play simultaneously, and thereby creating a larger mini festival, you can say. So we wanted to. Initially, we started out doing end-to-end testing of the app and the speaker, and that's what you can see on the photo on the right. You can see two phones. In this case, it's a Samsung phone and an iPhone, and they're part of the testing station. You can see the control panel of a soundbox, and you can see a lot of cables and various other things. What is not on this picture is also a MacBook that's having the role as controlling everything and running the scripts. And we were running end-to-end testing using a very common tool called Appium for testing mobile apps, including React Native apps, and that works pretty well. So we have been quite happy with that. Running Jenkins on the MacBook, and then a number of phones to test on. So that was the setup. And I was hired to write some of these end-to-end tests, and let me just tell you a little bit about what that experience gave us. So we ended up having around 15 different scenarios, which are like full use cases that a user can go through on their phone. And when automating these scenarios, we find that it takes a while to use Appium to do this. So we generally see 1 to 5 minutes per scenario. So the total time to run all the tests, all the scenarios on all the actual phones is now 2.5 hours. And getting feedback 2.5 hours on your pull requests is really too much. So this was, we wasn't completely satisfied with this. It wasn't a real improvement on manual testing, because you still get feedback quite a lot faster, but you also don't, it's not very robust either. So we did see quite a lot of false negatives where you had to basically run it again and see that it was failing with the exact same setup, but the second time it's passing. So it was really a false negative. So we were also looking into how can we maybe do better testing than these end-to-end tests. So to compare those two, if you look at end-to-end testing, it's much faster and cheaper than doing manual testing. And one of the nice thing about end-to-end testing is also that it does cover your entire system. So you will test not only your device, but also the interaction with the phone and the interaction with the server. And you are exposed to real-world timing and wireless noise, which is good from a testing perspective. It might be bad from a robustness perspective, but it's still a good thing. So it is, end-to-end testing can help you uncover really hard to reproduce issues by just relentlessly testing the same scenario over and over, and you can look at the Bluetooth logs and see what's going on when things eventually occasionally fail. On the other hand, we have unit testing, where there are a number of benefits, like there is no physical setup, so you can basically run unit tests just on your laptop. You get much faster feedback. You can get feedback from a large test suite in maybe a minute, instead of having to wait hours. And unit testing is usually also much more robust. You get basically 100%, almost 100% trustworthy feedback. So it's good to have a few of those end-to-end tests, but you should really use unit testing for most of your automated testing. If we look at how to do unit testing with React Native and Bluetooth, what we are doing at Soundbox is we are using the quite popular library called React Native BLE PLX, and we are going to mock that so that we can write unit tests with Jest, which is the normal common testing tool for React Native developers. So the simplest thing, and what we did initially, was to just write, like you normally do with unit testing, you write your mocks manually by hand. So you write some code to simulate the behavior of a Bluetooth device. and you will eventually hard code your Bluetooth messages and some traffic patterns. And these manual mocks are not really very reusable, so you end up having a lot of code to maintain with the manual mocks. But that's not really their biggest problem. The bigger problem is that manual mocks really lie to us, because when we test our app code in isolation with these unit tests and manual mocks, then what happens when something changes in the protocol, or maybe you get new firmware on the device, so the protocol changes, and if you then don't change the app code, then probably the app will break because the protocol is now different. But with manual mocks, the unit tests will still pass. And that's not really good from a testing perspective. So you have an app that breaks because something changed, but your tests still pass. So really, manual mocks, they lie to us. And we would like to get the best of both worlds. So end-to-end testing provides us with true integration testing, and we would like the speed and robustness of unit testing. And that's what we can do if we use mock recording. And that's what this talk is about. And I've been doing mock recording for many years, not specifically for Bluetooth, but for normal web traffic, for HTTP, for web services. So testing web front ends by recording HTTP traffic. And what I did here was to leverage that learning and apply it specifically for React Native BLE PLX library. So let's take a look at how that works. So the core of this method is to have a recording. So occasionally, maybe once a week or something, we will run on the phone against the actual physical device. So we will use an actual device like this control unit from the Soundbox, and then we run an app recorder on the phone and record traffic with the device. And we store those recordings in a JSON file that we keep in our Git repository. And those recordings are then like reusable mocks. So when we run Jest on our computer, we want to test various components and various pages in our app. So we write Jest tests that will use these recordings, and we can run these tests really fast, and we can run them all the time. But because the recordings really come from an actual recording of the traffic with the device, this is true integration testing, because the messages that we recorded are actual messages that have been transferred when we communicate with the device. So let's look at how it looks. So you record traffic occasionally, maybe weekly, or maybe whenever you make a protocol change on a PR, where you change both the firmware code and the app, you will run this again to record the changes in the traffic. And you can also in this recorder you can verify specific expectations about values that might change every time you run a test or something. And I'll get back to that. So we run this on the phone, and you can see on the video here how the phone will run through various steps, connect to the device, verify power state, scan for device, connect, discover, read device stuff, monitor stuff, etc., etc. So with this recording, we can now write tests for the app. And those tests are like normal tests, except that they're really fast and they are using real traffic. So in this particular case, I'm showing you a subset of a test that just demonstrates how to connect to the device. And we exchange around 50 BLE messages in this case. And as you can see, the test runs in about 200 milliseconds. So you can run these tests. You can run quite a lot of these tests as often as you really like. So how does these recordings look like? They are quite simple. They basically mirror the API of React Native BLE PLX. So it's just a long list of records, and each record is either a command or an event or a few other things that we can that can be done with the BLE PLX library. And we just record all the requests and all the responses in this recording file. So when we want to use such a recording, we have to mock React Native BLE PLX, and using the tool that this talk is about, which is called React Native BLE PLX Mock Recorder, then we can just use that tool to automatically mock React Native BLE PLX like this. So the usual jest mock file will just be these 5 lines. And then you write your app tests using jest just as you would like to write it, basically. So in this case here, we are, the first few lines, we are reading the JSON file with the recording, and we are configuring the BLE manager to use this recording as a mock. And then we can just use React testing library to render whatever component. In this case, it's a device list screen. It's actually from a different app. It's not the Soundbox app in this case. So we render a device list screen, and then we can control the recording. What timing do we want to do? So we can play back and forth, we can play forward in the recording until specific labels that we have put into the recording. And here we can also just continue with the testing, click on things in the UI, and then we can verify that things are showing data that's coming from the recording. So we run through normal app testing without having a physical speaker and the timing of that. So we get really fast and robust tests. The recorder app needs to be a dedicated app that's dedicated to recording this traffic. It's basically a very lightweight React Native app, and you can initialize it. You can see the command at the bottom. So that's how you initialize a new recorder app using the provided tool. It also has a template, so you can just get started by using that template, and then you have a recorder. I mean, it's basically just a small test runner that you can write tests for that you then generate traffic. And the reason we do it in this way, instead of reusing the app tests for having those in both playback and recording mode, that's not really possible. You cannot really run Jest on the phone, unfortunately, and also you cannot really run React Native BLE PLX on a laptop. So we need to do it this way, and it also has a number of benefits that we'll get back to. So how do you write such a recorder app? You basically write a number of small tests where you simulate or generate the actual traffic that you're interested in having in your recording. So before the tests start, you have to start the recorder. Then you do the things with BLE Manager like you would normally do, like listen for state change events, starting a device scan and looking for scan events, and putting in labels in the recording. You control exactly how you do that. And then when you're done, you save the recording, which you can then use. So architecturally, it looks like this. And if we go through it in steps, we can see that when we are running the app in production and we are not testing, this is real, a user will use the app, then the app just uses BLE PLX to talk to the firmware running on the device over BLE. And when we are running the recorder, we will instrument BLE PLX with this recorder module, so that every command and event we send back and forth to BLE PLX and the firmware will be recorded into this recording file. And then finally, when you want to run your app tests, we are completely not having the phone or the device in the picture at all. We are just running on the computer, running really fast, just running the app test, no build step included either, because this is just JavaScript. So you can just run your app tests against the app, and the app is using the mocked BLE for all the responses. So it looks like this. So now we have time for questions, except that I did this recording a month ago, so I can't really wait for your actual questions. So I just try to imagine what questions would you like to ask. So I have answered a few of those. So let's see. So if we are more than one developer on this team, and every developer have their own device, and with BLE, every device has their own device ID and stuff like that, how do you handle that? Do you put the device IDs directly in the recordings? And we do put device ID in recordings, but you can specify a canonical device ID so that every developer can have their own local device, and we will only connect to those recognized devices. But what is being put into the recording file is the canonical ID, so that you don't get diffs in the recording file every time someone else does a recording, because it's only the canonical ID that's being used. Another question is, what about values that by their very nature just changes all the time? There are a number of characteristics that have this that are like that, and for instance, our SSI or a battery level or maybe even the volume control might be set at different values between different recordings. And again, we would like the recording to use a canonical value. So as you can see here, you can specify the recorded value. So if you follow the test, we say BLE recorder Q recorded value. So we will say that we will record a value of 42, specifically for this battery level thing. And then we read the characteristic from the device, and it will probably return a different value. But what we put into the recording file will always be 42. So again, we don't have a lot of changes around every time somebody makes a recording. But read characteristic for device will still return the actual value when you're running the actual recording. And we can leverage that in the test, as you can see here, to verify that battery level, for example, should always be a number between 0 and 100. So we verify that in the test. So that becomes part of the test. So the recording app is also doing a little bit of the actual integration testing against the device. And what about still doing manual mocking? Because if we have at least one integration test per BLE message or message type, then we are really having a good enough integration test. And you sometimes might want to do additional testing where you, for instance, do a large number of tests where you put in some parameters, you do boundary testing or combinatorial testing. Maybe you want to test corner cases with battery level. What if it's 0 or what if it's 100? And you can easily use manually mocked BLE traffic with this library. So as you can see here, you just basically pass in another list of records that you write by hand. So that's a good way of combining your integration testing with combinatorial testing. The last thing here is a developer improvement, because one of the nasty things about BLE traffic is that it is quite low level, and it usually or always refers to services and characteristics by UUID, for example. And maybe eventually you will know all these UUIDs automatically, but also values are base 64 encoded, and it's sometimes really hard to read all these long numbers and these encoded values. So what we do in the tool here is that we add to the recording also a debug section where we are basically able to translate the service and characteristic UUIDs using a translation that you provide in the recorder app. And also the values will automatically be translated if it's possible. So at least to hex as a buffer, and if all the characters, all the bytes are ASCII, then we also show the ASCII string. So that makes it easier to read as well. And that's what I had to talk about today. So you can read more on the blog post that I wrote about this. You can scan the QR code to go to this URL. The tool itself is on GitHub, on React Native BLE PLX mock recorder, and there is a package on NPM that you can install. There is plenty of guides in the repo already, so it should be quite easy to follow. But otherwise, you're also very welcome to reach out to me. I am available on Twitter. And of course, there are still improvements that can be made to this tool. So I'm also very interested if someone starts using this and to get contributions from you. Thank you for listening.
Thank you very much, Lars, for this talk. All I can say is that I wish your library was out there when I was working on a Bluetooth application myself, because tested right, it was kind of hard. Now moving on to another speaker, the first one from the real-time communication blog, Akshat. He's going to talk about real-time video communication with WebRTC. Now, WebRTC is a protocol, a concept of adding video streaming capabilities to your applications, and Akshat is going to show us how to do it, followed with some examples, as well as break down the architecture and some of the WebRTC concepts in general, so that we all have better understanding at a conceptual level of how to do it with React Native. So Akshat, just can't wait to see what kind of experiences, real-time streaming experiences you've done with React Native, and how we can make sure that we know how to do it right in our applications as well.
Hey everyone, so the topic for next 20-30 minutes for next presentation is real-time video communication with React Native and WebRTC. So before we get started on the topic, some quick introduction. I am Akshat Paul. I'm an author and a developer in this field of software development for almost 12 years now. Have built all kind of applications, mobile apps, web apps, DevOps these days. I'm also co-founder of company 360, which is trying to change the way legal works in India. From your incorporation to your agreements, your ESOP agreements, to your intellectual property needs like trademark, copyright, patents, all with just few clicks, backed up with solid technology. You can find me on Twitter at Paul Akshat, and to know more about my technology adventures, you can have a look at akshatpaul.com. I keep it up to date. I'm always available on all the social media mediums. My DMs are open, so if you want to discuss about your next mobile app, or if you're stuck on React Native bug or an issue, just buzz me, and I'm happy to help. As I mentioned, I'm author of few books and also technical reviewer and editor for a few more. Most recently on React Native for mobile development with Apress and Ruby workshop. So do have a look. These books are available wherever books are sold, on Amazon and everywhere else. And if you have any doubt, any queries on these topics and subjects, happy to connect and get back to you on it. These are few of previous events in the last few years where I've given a talk. Of course, React Native EU. This is my third time, and also attended it way back in live session pre-pandemic era. Some other conferences like DevOps Days, React Global Summit, RubyConf India, and you can find most of these talks on YouTube. So do have a look and learn, share with like-minded people. And if you have any inputs for me, do buzz me and we can connect. So let's get started with the agenda for this presentation of this talk. Very simple 3 points agenda we have for this talk. What is WebRTC? What is the buzz about? Quick introduction about this project. How does it work? What are the various components of this architecture? And then how can we implement it with React Native? With React Native, we'll try to keep it simple, that everything runs on your local very easily. And my ultimate agenda for this talk is that by end of my presentation, you are comfortable with the WebRTC and can play around with it and maybe include it in your next application, some video calling or a group calling feature. So let's get started with point 1 of our agenda. So what is a WebRTC? WebRTC is Web Real-Time Communication. It does have a full form, and it's a free and open source project providing browsers, mobile applications with real-time communication via simple APIs that enable building rich, high-quality, real-time communication application which can be developed in the browser with the help of mobile platforms, IoT devices, and allow them to communicate via a common set of protocols. In layman language, WebRTC helps building peer-to-peer real-time audio-video streams between 2 or more parties, and this can be achieved purely on browser. And of course, we can then use it in our mobile applications also, and other types of form factors. It's really a simple way to build these very complex group call, video calling applications. And in last few years, you must have observed that lot of applications in the browser are now available for video calling, group calling, because of the whole pandemic thing. It's pretty much now it has become mandatory to have these features, and we can see a very popular example here in this image where during a legal hearing and a lawyer was not able to switch off the filters and continued to do the group call in the filter, and did mention that he was not a cat. So this is how ubiquitous the feature of group call and video calling has become. And it has become easy for developers like us to implement this feature using WebRTC in our application. So if you are one of those who want to capitalize this work from home boom happening, WebRTC is the API you are looking for. Because this feature is, as I mentioned, has become very common in most of the applications these days, and WebRTC helps in building a peer-to-peer connection very easily between two or more parties. However, this peer-to-peer connection architecture is kind of debatable, but there are ways to solve it, because in real world peer-to-peer connection is sometimes not possible. But of course, there are ways to work around it, and we'll discuss them later in the presentation. However, in our demo purpose, because we will be building everything on local, we will be having our peer-to-peer connection only. So how does a WebRTC application work? So at a very high level, we all know it establishes a peer-to-peer connection, and the two parties, two devices or browser, they communicate and transfer video, audio, data with each other directly. So this is a very simplistic view of a WebRTC application, but this is not totally correct and not realistic, because how will two parties know about each other till the time they know what is their exactly location, and how will they find each other in order to start establishing this connection? So if you hear or see at a lot of places that WebRTC requires no servers and it's absolutely direct peer-to-peer connection, that is not the case. Even in our example, we will be setting up a quick server in order to establish connection further. So what is that server? The most minimalistically, we require something called a signaling server. And what signaling server allows is that it allows two parties to securely exchange connection data. But once the connection is established, the media or the data between the two parties is not touched by the signaling server. Basically, then this system becomes a peer-to-peer connection and also very secure, because now the interaction is only between the two parties. And how does a signaling server achieves this? It does this with first creating an offer which is shared by the other by the second party or the other party. It receives an answer, and then the connection is established. This offer contains information like codecs, bandwidth, IP address, but nothing related to media. The media, as you can see, number 5, which is the media that is always interacted between the browser or the devices themselves only. Hence, it's very secure. So that is how signaling server, which is the first part of WebRTC, works. But is this also very realistic, or is it possible in the real world? Let's explore that. So there is one issue with this system which we see in front of us. There is a problem right here that in the real world, unlike the ideal world, when two parties are at distance, or especially in a corporate environment, they usually sit behind a firewall with their IPs consistently changing. Now this becomes very tough, and to establish connection from networking point of view, it becomes close to impossible. But here comes a standard framework which is called ICE that comes to our rescue, which is called Interactive Connectivity Establishment. This helps clients or peers to coordinate the discovery of their public facing IP addresses. Both the peers here generate list of ICE candidates. These ICE candidates contains IP addresses and ports. ICE then tries best to find the path to connect with the other peers. How does it do that? Using the host address, which is obtained from the respective peer or device operating system. WebRTC achieves this in the background. How it makes use of ICE is in the background with the help of a stun server, and that is what we will know next. So essentially there are two servers involved in a WebRTC system, which is a signaling server and then a stun server. So let's look at what is a stun server and how does it operate. So a stun server is basically, it has a full form too, which is session traversal utilities for NAT. But in short, a stun server is something which you are going to use most of the time while building a WebRTC application. It is a preferred choice for your signaling server also. How it works in a WebRTC connection is that it asks and also answers one question: what is the IP address? And this is essential because if we are going to have a peer-to-peer connection directly between the two parties or more, then we must have a unique identifier for each of them, and this unique identifier is the IP address. For a vast majority of WebRTC calls, a stun server is going to make this identification easily for each member and will be able to establish peer-to-peer connection. And once this connection is made, the media can begin flowing between these peers. It is simple, it is quick, and it does much of the work in most of the cases. However, there are times when stun server cannot get the job done. In that case, we do have a backup, and that backup is called turn server. So there will be are times when you cannot get a unique IP address of one or both or all the peers, especially in a very secure environment where often information is restricted, maybe a government organization or some highly secure corporates due to the firewalls, etc. And you cannot get direct IP for the peers, and it becomes impossible to communicate with communication between one peer to another, and that is the time we turn to our backup option, which is called a turn server. A turn server is it also has a full form, which is traversal using relays around NAT. What it does is that the server goes around the network address, essentially traversing the connection using relays. So when a stun server cannot establish a connection between two peers, a turn server steps in as an intermediary. It is, of course, very counterintuitive in a WebRTC connection and not ideal, since it will definitely add some latency to the call. But in case you are not able to receive a direct IP with the stun server, the only option left is no connection at all. So in that case, turn server is a good backup option. Of course, there are some points to be taken in mind. Using a turn server, of course, adds to the cost of your infrastructure. As the reeling adds more load, it's not straightforward and simple like a stun server. And the more often you use a turn server, the more traffic is directed through it. and eventually the turn server become a farm of turn servers. So using it as little as possible is a good idea, and using it like a backup is a good approach. So next is our React Native WebRTC demo application time. The source code for this application, you can find it on github.com/Akshat Paul/RNEU21, and you can, this is the final code, and you can check it out and maybe set it up on your local, play around. There are two parts to this application. One is the server side, other is the application, which is our client application, which will use React Native. That is our client app for our peers, which is basically in my case the emulator and our my Android device, which will connect to our server, which is a Node server. Few key packages during our installation for server side and applications and client side are Express, peer, socket ID, UUID, which we are going to use setup install on our server side, along with Morgan as a dev dependency. For our application, client application, of course, React Native is there. Beside Redux, socket IO, we will be also using a package called React Native Web RTC. The purpose of this this module is that it really allows us to use WebRTC just how we can use it in a browser. So it really does the heavy loading for us. You can check out its GitHub repo. There's a lot of sample code available there. Even I have made a use of that sample code, and it's very helpful. Cool. Let's now check out the code on our server side. So on server side, what we are doing here is that one, of course, we are initializing Express. We are then in the first part, you see that we are generating client ID, which will be assigned to our peers. These peers will interact with /myPeer in order to get this client ID, this randomly generated ID. We are hosting this server on port 5000, and that's all. And we can run this code. To see if our server is running properly, and that's all. So our server side of things is running fine. So let's now look at the code, keep a part of the code on the client side. So here on the client side of the application, one of the most important part is using the React Native WebRTC module. You can actually refer its GitHub repo, and there is some sample code, and you can simply use the code on the right side. You see is from the GitHub repo, and you can simply use it and load it in your component did mount. The purpose here is that what React Native Web RTC is doing, that it is accessing our media device so that it can get the video, and which we can then use it through the stream in any of the boxes we can create for the group call. So simply use this code as it is, and it works fine. Next part of the client side, the key part to the on the client side application is the socket IO and peer.js setup. Here what we are doing is that on the left side you can see we are using the URI which is of our server, which is basically of our local machine of our node server, which is running on port 5000. And we are using the same name as myPeer, which is in our server side, and we are connecting to our server. And if the connection is of course successful, we'll get to know that the client is connected. We are also creating a common room ID, as you can see on the right. It has to be common because we want to create a group call and we want multiple peers to join the same room. With my stream, we can dispatch our video stream, and with add stream we dispatch basically the stream of the peer, and then we load it on our application. So let's now run our client side application to see if it works fine. Yeah, so this will take a bit of time, so let me just fast forward this. So now we can see our build is successful. Our server is also working fine. It's connected. Our application is loaded, and on our simulator we see two streams. The top one is from my local machine, my Mac machine, and the bottom one is coming from my Android device. Due to some permission issue, you can't see the videos, but the streams are coming successfully. Also, we can see on our terminal we had console logged, and we can see data from two streams printed here. So that is successful. Coming back to our presentation, beside creating your own server in order to implement a WebRTC React Native application, you can actually use third-party servers like Firebase, Twilio, which are highly scalable and are absolutely ready for your existing applications or any production grade applications. We are now drawing close towards end of this presentation, and I'm not sure if you are still thinking that should I try WebRTC or is it worthy of my time. But WebRTC is really spreading like wildfire, especially in this era of work from home and in this post-pandemic world where most of us are working remotely. It's getting used in very places where we never think. Of course, video calls is something we always think and we can associate with WebRTC, but it's also getting used in places like telemedicines where doctor and patient can get connected using a robot, or in drones where the video streaming becomes way easier between the hardware and the smartphone. And of course, with video calls are now becoming slowly a key feature for any application, and implementing with WebRTC is way easier, and there are a lot of benefits. You can use it and make it part of your existing application. Easily embedding with your existing application. It is secure, and its implementation is really easy. Video streaming used to be a very complex feature years ago, but now it has become really easy, and especially with this combination of WebRTC and React Native makes it really easy for us developers. So guys, that's a wrap. Thank you so much for attending my talk and joining React Native EU remotely. Hope next year we all meet at React Native EU conference and maybe hang out and jam a bit code together at the conference. Once again, thank you so much. Stay connected and stay safe. Thanks.
Thank you, Akshat, for this talk, and I guess, kudos on doing live coding session with something such as advanced at WebRTC, because it's something that can go wrong, I guess, and this is a sort of environment where things like to go wrong. So I'm happy that everything worked out well, and I'm hoping that you all, and I'm talking now to the people listening us on a live stream, are just as excited as I am myself about WebRTC, and will be implementing that in the nearest future. Now, moving on to the last speaker that we have today, Wojciech, working at Channels. He's going to talk about something similar but related to voice. So making a voice calling application, like another Skype. Also discussing a bit of WebRTC in his talk, as well as some of the frameworks on iOS and Android that you can use to make that happen. And he's going to talk about an application that he has been working on. So another great talk, speaking about real-life production experience. So I just can't wait to see what he has prepared for us today. Wojciech, like I said, show us how to build VoIP applications with React Native the right way.
Hello, welcome everyone. My name is Wojciech Kwiatek, and today I'll talk about creating your VoIP applications in React Native. So I'll talk about basics. So we'll see how to start with the VoIP apps and what they really are and what problems you can meet during the development or of such kind of the app. So, but first things first. So, as I said, my name is Wojciech Kwiatek. I'm a CTO at Channels. So we are creating the product, which is a business phone app So you can find it on channels.app. I'm a JavaScript developer, roughly 10 years now, and I'm also a trainer and mentor when it comes to this field. So when it comes to technology that I was involved in, I actually did most of it looks like I started with some jQuery, Ember, Knockout.js, and going through Angular 2, Vue.js, and of course the React and the React Native recently. So I'm not only coding right now, I'm also trying to bridge the gap between the tech and business. So I'm also that guy who's actually checking if the business ideas are really doable and what kind of technology can help the business to grow. Okay, so you can find myself on a GitHub or on a Twitter. So here are the links. And let's start with the topic. So just as the beginning, so what actually is a VoIP app? So when we talk about the VoIP apps, you probably are thinking of something like Zoom, Messenger, Teams, WhatsApp, and Skype. So these are the main, one of the main apps that are actually used to connect two peers together. So basically, when you're calling someone, either with the audio or video, so it's basically done via the VoIP app. So it doesn't necessarily has to be a phone number at the other end. So it may be just the connection between two apps, right? So that's what most of them does. And they also are doing the mobile apps. So this is something that we will try to see how to create such kind of app. So when it comes to some kind of the ingredients, so what do we need to create such an app? So I put here three things which I consider the main one. So the first is access to the hardware, so to the microphone or camera. So we need to get the permission from the user. We need to get the stream, the audio stream or the video stream from the user, and then we can process it later. So that's the very basic thing. So to somehow get the stream. Then the second thing is we need a connection between these two endpoints. By endpoints, I mean two users, two or more users, because it doesn't necessarily need to have to be like we have just two users. We may have a group call or something like this. So we need connection between the participants. So that's the second thing. And the third thing, which applies especially to the native apps, is that you need some way to communicate to the API that your phone is calling. So WhatsApp does it, some Hangouts or Zoom or Meet does it, that if someone calls you, they're showing you or your phone is ringing. So that's the third thing. So we need to somehow connect to the phone API to basically show that the call is incoming. So let's start with the first point. So we need a set of permissions. So the way I put it in as a separate topic, because recently Android and iOS are trying to protect their users, and they're trying to give them visibility of what's going on with their devices. So a few years ago it was like, okay, on Android you get the permission for everything actually, and you could do whatever you want. But these times are gone. So now we need on both systems, we need to ask for permissions, for specific permissions. If you want to use microphone, the user has to give you the access. And why this is such a problem? First, because the guidelines, especially on iOS, requires you to have a working app even without the permissions. So even if we have a calling app and user don't give you any access to the microphone, it still needs to work somehow. It may give some kind of information that, okay, you don't have access to the microphone, so please give it to us so we will be able to make a call. But yes, still it needs to be a working app somehow. The second thing is that there's something which is called the call screen on Android, and it sometimes may be different from device to device on how it looks like and how it behaves. So sometimes you may need to educate users a little bit more on how to give the access to that, because it may not be that simple, like you can see on the screen that the app would like to access your microphone and that's it. Of course, all of these permissions can be reversed. So it can be basically taken from you for the given app. So bear that in mind that you should always have a fallback on that, especially when describing to describe to the user what's going on. Okay, when we actually have a permissions, it will be pretty straightforward to get the audio stream. But to get the audio stream, we need some kind of solution to that. And thanks to the WebRTC, we can use it. So we'll talk about the WebRTC first when it comes to the JavaScript, because WebRTC actually has a lot of years right now. So it's like about 10 years, I guess. So actually, the WebRTC is for a long time with us. However, this year came the WebRTC 1.0. So this is also a good step because previously, when using WebRTC, you may hit a wall when it comes to the interoperability. I mean, like there could be different implementations of the same thing. For example, on Chrome and on Firefox. So the different APIs. That the APIs could work in a different way. After this 1.0 version, it should not be a problem at all. So you probably will not need any kind of adapters, polyfills, and things like that to make WebRTC work on every major browser. What's also important to note is that actually every single browser, even the Safari on iOS or Opera on Linux, will work. So you can use WebRTC between actually most of today's browsers. So, but yeah, let's talk a little bit on how the WebRTC connection look like, because usually what you can find on the internet is just like WebRTC is a peer-to-peer connection, and that's actually true, of course, but there's a little bit more behind that, because to have the peer-to-peer connection, you need to somehow discover these two peers. And this discovering these two peers, is usually done through some external server. This external server are called stun and turn. These are the different technologies to achieve the same thing. I'll not go into the details when it comes to the stun and turn. I'll attach the links at the very end, so you can read more about it. However, the idea behind it is that the WebRTC supports both of them, and both of them are basically to enable the connection between two peers, so to make them talk to each other. However, before you basically send the media between two peers, you will need to set up the connection, and that's where this middleware kicks in. Okay, so we have here some high-level implementation of the WebRTC connection. So first, we need to get and share local and remote descriptions. So it means that we need to share the metadata about the local media in some specified format. This format, we don't have to care about it that much because that's part of the WebRTC thing. But what we need to know is that we need to send our metadata about what's our local stream on one device to another device. So for example, what's the resolution? What codecs do they support? We need to push that information to the other party. And the second thing is to make our make the peers discoverable. So it's about the servers that we talked just before. So we need to get the information from the other peer and share the information about myself to the other peer. So it's called the ICE candidates. So we need to send this to get this candidate and send it to the other party. And as we have these two things, we actually will have the WebRTC connection. So it means we are allowed, or we know how to send the data. So the last part is basically send the data, which we get from the particular device for every single user. Okay, I'll try to share some code here. So this is like not the working snippet, it's more like an idea on how it could look like. Of course, the APIs here are the real ones. However, what we can see here, we can see the configuration object, which has an URL to the public SAN server. So it means you don't have to have your own server for that. You may need the Google ones, and that's actually pretty safe. But probably if you later on will use your own app, you may need your own server. But yeah, let's, for the example, take the Google ones, and you're creating the RTC peer connection with that, which means that this is the object that we will attach other information. So for example, here you have, I will put that later on. So this one, you will have the created offer from the peer connection. So we are creating the offer and we are setting this offer to our peer connection, and we are sending this through some signaling channel. I omitted this one because there's a signaling channel, which is kind of mock. When it comes to the WebRTC implementation or actually description, the signaling is not defined. It means this signaling channel can be anything. So for example, in this case, it's some kind of WebSocket thing, which sends to the node server, and the node server manages this signaling. So you have the send method to every other channel of the WebRTC, and also add event listener on the message. So yeah, let's go here. So we are setting the local description. We are putting this offer into the signaling channel. Okay, so then we go to the receiver. We have the same thing when it comes to creating a peer connection, and we have the listener for the message with the offer. So we have we are taking this one on the receiver part, and we are setting the remote description. And as we set the remote description, we are creating the answer, and we are setting the local description with this answer, and we are sending the answer. So basically, receiver gets the offer, creates, sets the offer as a remote description, creates the answer, sets it as a local description, and puts the answer back. And back to the sender, we have add event listener for the message with the answer, where we are setting the remote description. So this was the first part about the negotiating the resolutions, the codecs, and so on. So the metadata about what can we send and what can we receive. The other part is that both sender and receiver are putting the listener to the ICE candidate, and this is what the SAN server actually does. And we should, as we get the ICE candidate, we should send it to the other channel. Yeah, so we are sending from the one peer to another the ICE candidate, and as we receive it, we are adding the ICE candidate to the peer connection. And now, after these two things, this means that we have the networking set up, so we are allowed to send the media. So as we have the connection state changed here, the event listener for that, we can see that the connection state changed to the connected. Then we are good to go. We can send the media. Okay, things are getting complicated. So you can see that we just took a look at the very beginning of this, let's say, conversation. So we just set up the connection between the peers with the WebRTC. We didn't even send the media yet. So to be honest, the whole WebRTC is a very powerful tool, but it's definitely not that easy. And when it comes to the VoIP, there's something called session initiation protocol. So there's some very special protocol, and there are some tools built on top of that allows, that works also on the top of the WebRTC, that allows us to do things a little bit simpler. What I mean by that, the SIP can, or actually this protocol can set up a session between the endpoints. So what we already did between two peers of the pure WebRTC, it can negotiate the media parameters, their specs. So yes, one more time, exactly the same what we did. It can manage the session. So it can terminate the session, it can adjust the parameters during the session. You can substitute the tracks, for example, if you want to transfer the call to someone else, or if you want to use a different track. So for example, you put your headphones on. So all of this is already handled in some tools. So when I think of some tools, there are some JS libraries for that. So there is JS SIP and SIP.js, when the SIP.js is actually a fork of JS SIP. And they are creating a kind of abstraction over the WebRTC, so you don't need to care of every single thing which you would do with the WebRTC. What's more, it actually takes care of the signaling. So what it means that when we have this signaling server or whatever that was marked under the example, now all of this is being handled by the SIP server. That's also downside because you have to use a SIP server, but the upside is that it's already done. So there are some servers like Camelio, Asterisk, or FreeSwitch, and more of them even. So I would just name some popular ones to take care of the signaling thing, to take care of this negotiation, and so on. So what I would say that if you want to use the cloud or you want to create a cloud telephony application, you probably will end up with the SIP on the top of the WebRTC. So, but I strongly encourage you, if you want to give it a try, let's start with the pure WebRTC and see where it goes, and then let's go to the SIP and see how it's different, how it's much more helpful with that. Okay, so the question is, if this signaling, if the SIP is enough. I would say for the whole application, it's not yet everything, because what we have here, what we discussed, is just a part of sending the media. So even though we started with the WebRTC with this initiation part, then with the signaling, it's still about the sending media. So you have the whole bunch of things that you would also want to send via the REST API, via GraphQL, or even via another WebSockets. So bear in mind that all of this that we are talking about, the signaling thing, is all about just the call, just the video or audio call. Okay, so we talked a little bit about the WebRTC, but where's the React Native in here? So the case is that thanks to React Native WebRTC library, all of this is also true for the React Native. So you can use all of this API also in the React Native app. So what's cool about this is that this package also takes care of polluting the global JavaScript namespace with the WebRTC globals. So for example, if the library like JSTip uses some global APIs like window apps or WebRTC something, it's able to use it as in normal JavaScript application. So this package is pretty cool. So it requires some configuration step as far as I remember, but after that it's pretty smooth. So definitely should use that when it comes to the WebRTC. Okay, so now that's the time we can write the app, and that's true because after all these steps, we can now make a connection between two apps. I mean, between two instances of the app. So between the two users, we can send the voice, send the video, and all these technologies that we talked about up to this time should be enough. But there's one problem when it comes to the mobiles. What if the app goes background? Because this is the problem that we don't really have on the web apps, because usually they are done in the way that you're opening tab, you are doing something, even you are calling, you are having a mid conversation, you're closing the tab, that's gone. But when it comes to the mobiles, you put the mobile phone in a pocket, and then you actually wanted it to ring as it's required. So all the other apps are doing that, right? So WhatsApp is calling, when someone is calling you on WhatsApp, it's basically ringing as any other phone. So this is something that we want to achieve also in our app, right? So to achieve this thing, we would need two things. So the first one is the push notifications. Also, we have a slight difference here when it comes to the Android and iOS. So for iOS, we have two kinds of notifications. So we have push notifications and VoIP push notifications. The VoIP ones are meant to be used only for signaling the call. So for example, let's go back to the example. If someone calls you on WhatsApp, so the WhatsApp uses VoIP push notification to notify your device that there's an incoming call. On Android, on the other side, there are just notifications, and you are allowed basically to create such a call screen from any notification. Why is this important? Because on iOS, you definitely should use the VoIP because the priority of such a notification is much higher. And starting with iOS 13, it's actually strictly bound to the call screen. So let's talk about the call screens then. So with iOS 10 in 2016, Apple introduced something which is called Call Kit. The Call Kit is a set of APIs which allows you to communicate to your phone call system. By call system, I mean you can basically show call screen with your data, with your apps data. So and that's what main competitors or main companies are actually using right now. It was even more prominent starting with iOS 13, because starting from iOS 13, they actually forced you to use VoIP notifications with the call screen together. So every time the VoIP notification comes in to the iOS app, it needs to be reported as a call. So the call screen is being popped up. So the only way then to use it, you should follow the rule that you should use the VoIP push notifications only for incoming calls. And for the other, you should use the regular push notifications of the iOS. When it comes to the Android, you have the priorities. So we are managing this with priorities of notifications, and one of them are simply showing the call screen, while others are behaving like another notifications. Okay, But when it comes to the call kit, there's a library which is called React Native Call Keep. And this Call Keep manages both Call Kit on iOS and connection services on Android, which means that we can show the call screen on both Android and iOS using this package. So this is the package that probably is the only one on the market that will handle that without touching the native stuff in here. So I strongly encourage you to take a look at that when it comes to handling the call kit and the connection services on Android. So this is how it looks like when it comes to the incoming call on Android. So we have basically our own screen, then the notification, which is the incoming call notification strictly from Android in this case. We are answering the call, and that's the call screen of Android. So that's what you can achieve using this call keep React Native package. Okay, so I bet now we covered all of the pieces that are needed to create such an app. Of course, this is a very sneak peek overview of what's going on here because yeah, there's a lot more underneath that. But I hope you get some very basic knowledge on where to start on how these apps are actually looking under the hood. So just a quick recap. The first thing, think of permissions, because usually there will be more of that than just popping out the permission. You need to handle what's going on when user denies the permission, basically. Second thing, I bet the only, or actually the preferred way, or it might be the only way to do is the WebRTC. So you need to incorporate the WebRTC into the React Native app, and you may or you may not use the zip and the zip server. However, it depends on your use case. So you may need some simple thing when the WebRTC, the pure WebRTC, will be enough. But if you need the whole signaling thing, the whole negotiation thing covered, then the zip is the way to go. The thing about the call kit and connection services is very important when it comes to the background services, especially the incoming calls. So if you want to do the incoming calls properly, then you need to use the call kit on iOS and VoIP push notifications. On Android, there are push notifications, just the casual ones, and you have the connection services, which allows you to show the incoming call or outgoing call using the native screen. And there's a package which is called React Native Call Keep to handle both of them. Last but not least, as you're starting to work on some kind of VoIP application, see if you really need to create it from the scratch, because there are some tools on the market, there are some SDKs on the market like Twilio. We are also entering the train as challenge the app. So maybe some part of these VoIP applications are already done. Even if it's paid, it might be even cheaper to create some sort of VoIP application using such already built solutions. So thank you very much, and I'll attach also the links to some additional resources. And yeah, see you hopefully next year in person. Bye.
Thank you, Wojtek, for this talk, and I'm really happy that we got these two talks together so that we were able to actually compare the video streaming capabilities with the audio capabilities. So now we are fully equipped with the necessary knowledge needed to build video and audio-driven applications. And this wraps it up. So I'm hoping that you liked it. This was the second and actually the last day of React Native EU conference. And I'm hoping that you have got as much out of it as possible. Now I wanted also to thank very much to all of the speakers that have been part of this conference, all the great talks that they have created and recorded and prepared. This has been amazing, and I'm really, really happy that you were able to make it happen and were part of this conference. So once again, thank you very much for doing this. I also wanted to thank very much everybody who has actually submitted a talk submission to our RFP process. While you may have not been selected this time, I'm really happy that you have all taken part in React Native EU, and who knows, maybe next year will be your opportunity to be part of the React Native EU first or the second day. I also wanted to thank very much everybody who's been listening to us. It's been great that you have been with us today, being interactive on our Discord, Twitter, and all the social media. This conference is actually for you, so I'm happy that you were kind of interacting with us in real time, making sure that you are taking out of it as much as you can. And like I said, you can still leave your questions on our Discord channel, and we will be answering them on our React Native Show podcast soon after the conference. And don't forget to follow React Native EU on Twitter and Callstack on Twitter and use React Native EU hashtag. This is how you can stay up to date with not only React Native EU conference, but also as we release the recordings of the first and second day, as well as we answer your question. This is all that we will be broadcasting through our social media channels. I'm really hoping that you liked it, like I said, and I'm also hoping that another edition, the 6th edition, will happen again, but on-site in Wrocław. While you may not remember, the first 4 editions were happening, or 3rd editions were happening in Poland, on-site in Wrocław, but because of the global pandemic situation, we were actually forced to move it remotely, which has been working out quite nicely, but we still miss your faces because that was one of these opportunities where we can all interact with each other, shake our hands, and kind of get out of this remote reality and see how our Twitter and GitHub handles and avatars compare to our faces in real life. So like I said, I'm hoping that next year we see each other in person, and while this is just a hope because we got another 12 months for the conference, I just wanted to thank you once again for joining, and let's stay up to date in social media because that's the way how we can interact with each other while the pandemic is happening. Stay healthy, stay safe, and once again, thank you for staying with us for 2 days. It's been a pleasure. Bye-bye. This conference is brought to you by Callstack, React and React Native development experts.